So we're really excited to have you joining us today. This workshop is intended primarily to help our industry partners with writing their HACCP plans and getting some basic HACCP education to understand the reasons for the HACCP plan. And I am joined by Kim Messick. I'll just let you introduce yourself, Kim.
Hi everyone, I'm Kim Messick. I'll be answering all the questions y'all have in the chat. I'm the special processes analyst, so John's my senior. But if y'all have any questions, just let me know and I'll be answering them.
Okay. So once again, thank you everybody for joining us. I will ask that you put your questions in the chat and or raise your hand, but primarily please put your questions in the chat, and Kim will answer your questions, or she will pass the question to me. But we're very happy to answer questions. That's what we're here for. We've got a lot of industry folks as well as inspectors in this meeting. The reason for that is because we all benefit from each other's questions. We actually require our inspectors to participate in these workshops periodically as a continuing education requirement. So but it benefits everybody to ask questions. We have good discussion. So we are looking forward to doing this presentation for you. Kim, if you'll go ahead and start the recording, please.
You're all good.
All right. So let's see here. So we are recording this session. You should have all received the HACCP template that you requested. These are the templates that we provide to our industry folks in South Carolina. And we have found them to be extremely helpful in helping our industry folks get their plans written with the necessary content. You have also received a resources document. The file name was Appendix 1 Resources. We will be referring to that periodically through the morning. We mentioned about questions. This book that you see here is a fantastic resource. It's available from AFDO, and you can get to that page using that QR code. Please familiarize yourself with the Zoom toolbar, so you'll see where the reaction button is and the chat button. You should have also received an agenda. We will try to stick fairly close to that agenda. We should be done hopefully no later than 1 o'clock. For those of you who are South Carolina Department of Agriculture staff and South Carolina Public School culinary instructors, please drop your name and your organization in the chat so we will have a record of your attendance. Very important for our SCDA staff. That helps us to document your attendance for your continuing education requirements. And for those of you who are school culinary instructors, we need to have that documentation so that once you have completed both sessions and submitted a HACCP plan to us for review, then we will be able to provide you with the form to obtain the promised certificate renewal credit. We're very grateful to the South Carolina Department of Education for partnering with us in that way. So with that, let's get started. If I can get my mouse onto the right screen here. The food code, the FDA's food code, is the basis for retail regulations nationwide. I believe the total is like 43 states that have adopted the FDA food code in some version. We in South Carolina are currently on the 2017. Sorry. Let me back up here and share my screen. Screen 1, here we go. Sorry. Thank you, Kim. We currently are on the 2017 version of the food code, but we are in the process actually of updating to the 2022 version. So our regulations will be updated by early next year. The reason for the requirements for a HACCP plan is that these processes for reduced oxygen packaging are high-risk processes, and we'll get into the reason for that. So because of the risk level, it is necessary to have a validated and approved safety plan to control the potential hazards in the process. Everything that will be required as part of the HACCP plan is based on the current best science. And when we review your plans, we will be looking to make sure that, number one, the validation is in place for whatever you're going to be doing. If you're following the regulations, following the food code for reduced oxygen packaging processes, no further validation should be needed unless you are doing something that falls outside of the regulation, in which case we would need, here in South Carolina, we would be working with you to determine whether what you are doing has valid science supporting it. There are some variance possibilities where we would provide you with the information that supports it. Otherwise, you would have to obtain your own science, whether it's through a product assessment or some other published information. We would provide you guidance on what might be needed. But if you are following the food code, you should not be needing any additional validation, because everything in the food code and in your state regulations would be backed by science already. Again, the reason for having a HACCP plan is that the need is driven by food safety history. So the requirements may vary from state to state. We are aware of that. That may depend on the version of the food code. It may depend on other local agency policy or regulations, but I will be referring to the FDA 2022 food code. That is the basis for everything I'll be talking with you about today. So what we'll be covering today will be an introduction to HACCP. This is not a certification course. It is just an overview. For our industry folks, we want to respect your time by providing you information that is directly related to the process that you intend to pursue. Other HACCP courses out there really are not focused on retail. They are also not focused on reduced oxygen packaging processes. So that is one of the reasons why we have created this workshop, is to provide you the information you need to know and understand about these processes, so that you can then turn around and provide the necessary training to your staff that will be part of your HACCP team. So again, we are focused on FDA food code requirements. We'll be covering the prerequisite procedures. Those are procedures and policies that must be in place to support the effectiveness of your HACCP plan. We'll be covering the 7 principles of HACCP. We'll be talking also about the importance of compliance with the approved plan, as well as some of the most common violations that we see. And especially we'll be focusing on essential controls in the ROP processes. So we always get a lot of confusion from our customers, our industry customers. What is HACCP? What's that all about? It's confusing. It's a lot of work. We understand that. But our goal is to help you, first of all, develop a HACCP plan that is practical for retail without going, whole hog, so to speak, into a manufacturing style HACCP plan that is totally counterproductive. We want to keep it efficient, but as well as effective. So we want to dispel, any confusion you might have, any intimidation related to that requirement. Absolutely important that you recognize that your inspector is a partner. They're not the enemy. We are here to support you in doing the processes that you want to do safely. We do not want to change what you're doing unless a change is needed for safety reasons. So once again, it's absolutely important that you communicate honestly with your inspector, and absolutely feel free to contact us here in South Carolina, myself or Kim Messick. We are more than happy to assist you, answer your questions, provide guidance as you need to do an update to your plan, which happens from time to time. That's what we're here for. We are your partners. So the reasons for HACCP include what you see on the screen there. The types of process that we're talking about carry higher levels of risk due to the packaging process itself, other types of processes that may be hybridized with the packaging, such as curing sausages. It's really important that you understand that the nature of the process is what creates the risk in reduced oxygen packaging. So your procedures that you provide must include the necessary controls to maintain the safety of your process and of the end product. HACCP uses intentional and proactive science-based means to control specific significant hazards, and we'll be talking in more detail about that. In some cases, in some types of processes, the substitution of specific controls for general food code requirements is going to require the approval of a variance. So if you're doing straight up ROP per the food code, there is no need for a variance. It is not required because you're following the food code. But if you change something, for example, if you decide you want to use a preservative, then to extend shelf life beyond what the food code allows for your process, sous vide 7 days, storage of raw meat and poultry 30 days. But if you want to use a preservative, then that is going to take you outside of the normal requirements that would require variance for the use of the additive, as well as for extending the shelf life. So taking ownership of that approved plan is absolutely important. I cannot overemphasize that. The plan must be implemented and it must become the only way the approved process is done. And the reason is to protect consumers and your business from the potential hazards associated with the process. As I mentioned a couple minutes ago, our goal is not to change your process from what you're used to, but if a change is needed, we will discuss the reasons and provide guidance for an acceptable correction to the process. The bottom line, though, with HACCP is, and this is a little bit blunt, but failure to make a safety plan by default is planning to fail. So it's absolutely important to have a validated and approved plan in place. That is what we're all about today. So again, the reasons for HACCP, if you don't have a safety plan in place, if you're not following the safety plan, the consequences can be very severe to your business, not the least of which is public health consequences, sick customers. Hopefully nobody passes away as a result, but there is that risk, and that's why we need to manage the risk. But aside from the costs related to regulatory citations from failing to follow a plan, the economic costs include liability for medical expenses, civil liability lawsuits filed by injured customers, lost days of sales resulting from closure during the investigation, lost wages for employees, and short to medium term loss of customers as a result of bad publicity. So if you look at that Appendix 1 resource document, the first page there lists a number of examples of outbreaks that are related to different types of special processes. I'll give you 3 examples from our own experience here in South Carolina. First of all, there was a restaurant in 2019 that left some fried rice out on a counter over the weekend, and then they served it on Monday. This resulted in Bacillus cereus bacteria forming toxin, and there were 21 people sickened and 1 person died. That restaurant is now permanently closed because of the consequences of a liability lawsuit. Another one in the low country of South Carolina was a norovirus outbreak that resulted from just serious violations of health policy requirements. Norovirus, 290 confirmed cases, and our epidemiologists estimated nearly 700 total cases, including those that were not reported, milder cases. There was a settlement of nearly $1 million, paid out that was paid out in $5,000 portions to each complainant. That once again, this restaurant was permanently closed because of the consequences of that outbreak. And then lastly, in 2005, we had an outbreak from a barbecue restaurant in which a temperature sensor was failing in their smoker. And as a result, 304 people were sickened because of undercooked product. There were more than 50 people hospitalized, and there was one death, which resulted in a settlement of $710,000 paid to the family of the decedent. So again, I cannot overemphasize the importance of making sure that you have a valid and approved safety plan for these high-risk processes. And that comes down to not only having a safety plan, but just following basics, making sure thermometers are properly calibrated, the equipment's functioning properly, and so on. The three types of hazards that we're concerned with in any process include biological, chemical, and physical hazards. The biological hazards are the ones that are most challenging to control. These include bacteria, viruses, parasites, and in some cases, some of the molds or yeasts. I need to emphasize that biological hazards can be associated with raw foods of any sort, including residual on inadequately cleaned equipment, especially listeria, because it loves to find tiny little cracks and crevices in the equipment, cutting boards, and so on, where there's some food residue building up. Listeria then takes up residence, and it becomes very difficult to remove. And biofilm basically flakes off into food as it passes through the equipment. And although the case count nationally on an annual basis for listeria is fairly low, mortality rate is between 20 and 30%. So out of everybody attending this meeting, for example, if there are let's say there's 75 people in the meeting. I'm not sure, I don't see the number at the moment, but if there were 75 people in this meeting and we had an outbreak between all of us, that means that as many as about 20 people could die, and just about everybody would be hospitalized. So that's how serious listeria is. It loves biofilms on the equipment. Again, though, any raw commodity can potentially have some contamination with pathogens, even potentially at low levels, but it potentially is there. We have to be aware of that. So failure to follow regulations, equipment that's malfunctioning, such as let's say at your 3-compartment sink, if the sanitizer dispenser is not dispensing properly, which happens a lot, you could be under sanitizing, and that actually can result in those bacterial pathogens developing resistance to your sanitizer. Poor food worker health and hygiene practices can also contribute either from sick workers transmitting illness to food that they're handling, or those hygienic practices. The number one culprit is improper handling. The hands are big contributors to transport of pathogenic bacteria from places you would not think of onto the food. So it is absolutely important that employees follow the hygienic practice requirements. And in the templates we've provided, we have included a model health policy and a model hygienic practices policy, which basically summarize the requirements in Chapter 2 of the FDA Food Code. Chemical hazards can include naturally occurring toxins, such as shellfish toxins, histamine or scombroid toxin coming from temperature-abused fish, bacterial toxins such as Bacillus cereus toxin that I mentioned a few minutes ago, staph toxin, and Clostridium botulinum toxin. It's called botulism, which is one of the primary hazards we're concerned with today, listeria being the other. These are the two primary hazards associated with reduced oxygen packaging processes. Undeclared allergens are another type of chemical hazard, and they are a leading cause of recalls. Other chemical hazards that are potential include improperly used additives, such as if you're curing meat and you're using too much nitrite, that can result in a chemical hazard. Chemicals related to cleaning or maintenance or pest control. All of these can cause serious illness or injury, and in some cases, death. So we really have to focus on how we store those chemicals in the kitchen. We have to realize that chemical toxins generally are not going to be destroyed by cooking. Third category of potential hazards is physical hazards. Drop in the chat, please. What types of examples of physical hazards can you think of that could cause injury? Give us some examples, please, in the chat. Kim, if you would read out what you're seeing there, please.
We got a lot of plastic, wood, metal, jewelry, parts of equipment. Someone said hair, gloves, bones, fingernails, paint, nuts from machines, fingernails again.
Perfect. Great. So I like to pick on hair because that one comes up a lot, especially when we're talking with students. So FDA defines a physical hazard as any hard or sharp object that is at least 7 millimeters in its longest dimension and no more than 25 millimeters in its longest dimension. Basically, that's a 1/4 inch to 1 inch. Any object that's larger than that, you're likely to see it, right? But if it is smaller than that, you probably would never even notice it. So is hair actually a physical hazard? My somewhat humorous response to that is, well, only if you use a whole can of hairspray on it, in which case it becomes more likely a chemical hazard. It is not a hard or sharp object. So it's a disgusting factor, but it's not a physical hazard factor. Very good feedback, though. Thank you. Okay. So let's talk about the biological hazards. Once again, these are the hazards that are most difficult to control, so that's what we'll be focusing on today. Viruses, bacteria, parasites, molds, and yeast. So viruses require a living host in order to multiply. They're transmitted from one host to the next, either directly or potentially indirectly through surface contamination. The two viruses we're concerned with per the food code are norovirus and hepatitis A. Both of these are considered what we call fecal oral pathogens. So your health policy and your hygienic practices are especially important. Those are your primary controls for the viruses. Proper regular hand washing is absolutely essential as a preventive measure. These viruses will not be destroyed by low temperature cooking or in any process where there is no cooking step. So this is where, if you look at our template, if you have a template for sous vide cooking, you'll notice that we include employee health and hygiene policies at the steps where the food is being packaged before the cooking step. The reason for that is because if you are sous videing at a low temperature, let's say a beef steak at 130 degrees for 112 minutes, you will not destroy either of those viruses. The cooking temperatures specified in 3-401.11 in the food code are validated for destruction of salmonella and other bacterial pathogens, but not viruses. So it is absolutely essential that the employee who is prepping that food to be sous vide cooked must be following the health policy and proper hygienic practices. If they have had a significant exposure, then it would be up to you as the manager to consider whether that person should be restricted in their duties while there's that potential for viruses to persist from that exposure, even if they have no symptoms. So those viruses can be shed for a number of days or even weeks after a significant exposure, or after that employee has been ill and has recovered from the symptoms. Absolutely important to think about that. Bacteria are naturally occurring. Pathogenic bacteria can occur on or in any raw foods, resulting from contamination at farm or primary processing level. They can also be transferred from infected workers or from processing on unsanitary equipment. So sanitation procedures are absolutely important. The bacteria multiply as a result of favorable conditions, which we will talk about in a few minutes. Unlike the viruses, bacteria can multiply even on surfaces or on food that is not properly stored. So it's a very different method of control there. So E. coli, pathogenic strains of E. coli, Salmonella, Shigella, Staph, Listeria, Campylobacter. These are all bacterial pathogens, so we have to make sure we provide the necessary temperature controls to either properly destroy by cooking or to properly store. And Listeria monocytogenes is unique because it can multiply at temperatures as low as 31 degrees. So this is the reason why we have date marking requirements for ready-to-eat foods, no more than 7 days, and that is a safety date, including the day of preparation. So that means consume or discard by the end of that 7th day. Some of these bacteria produce toxins that are generally not going to be destroyed by cooking. So recall that example I gave you earlier of the Bacillus cereus poisoning incident that happened here in South Carolina. Once you have vacuum packaged the food at retail, no second trip is allowed through that vacuum packaging process. You're only allowed to package that food once. If a customer comes into your meat market, for example, and they see a 10-pound roast and they say, well, can I get a 5-pound roast? Can you break that down for me? You cannot vacuum package that product after breaking it down. If you've already vacuum packaged it once, you can break it down, but you cannot repackage that product. The reason for that is because if any toxin formation has occurred from Bacillus cereus or botulism, staph, toxin formation is cumulative and it will not be destroyed by cooking. So if the potential is there for toxin to form, it's going to continue forming when the conditions are right. The other issue with the bacterial pathogens, some in particular, produce spores, which are a survival mechanism. When the vegetative cell, as we call it, the bacteria itself encounters harsh conditions that are unfavorable, it will convert itself into a spore, which you could think of like a seed. It does that in order to protect itself. But then once the conditions are favorable, then that spore will activate and it goes back into its vegetative cell state, and it can then produce toxin, again, when those conditions are favorable. So this is why it is so important to maintain proper cold holding, proper cooling conditions, proper cooking. All of that figures together in controlling these pathogens. Parasites are another type of biological hazard. Parasites in particular can occur in wild game, wild caught fish, wild boar, bear meat, and so on. But they can also come from contaminated irrigation or processing water. I know we at this point have all heard about the cyclospora outbreak from lettuce. And you can be very sure that that would have come from either contaminated irrigation water or processing water. When it comes to row crops, those crops that grow low to the ground are especially prone to contamination from parasites that can be related to overhead irrigation plus improper fertilization. So that's just one example of how that contamination can occur. Molds and yeasts generally are a quality issue. However, some are toxic or they may produce toxins. So I know we've all heard of aflatoxin. That is one type of mold toxin. So especially, the black molds, we hear about those. Those produce toxin. Grains in particular are subject to aflatoxin being formed if the grain is not stored properly. Humidity builds up and the mold can grow and it can produce toxin. In your Appendix 1 handout package, that resource package, resource number 2 is from the Food Code, and that is a table of common biological hazards. We will be coming back to that a little bit later. Do we have any questions at this point?
Haven't been any through the chat.
Okay, so we good? Okay. So this is how bacteria multiply and how we use a combination of different control measures to control bacteria growth. All bacteria require favorable conditions. They require nutrients or food. They require a favorable pH that would allow them to grow. The ideal pH range for most bacteria is between 4.6 and 7.5. But those ranges vary depending on the type of pathogen. The next one is time. Given sufficient time and favorable conditions, bacterial populations will multiply. The next one is temperature. Normally, the general range in which bacteria can grow is between 41 and 135 degrees. That should sound very familiar to you. That is what we call the temperature danger zone. And especially between 70 and 135 degrees is the ideal range where you get the most aggressive growth of bacteria. I mentioned earlier, Listeria is a notable exception to that guideline because of the fact that it can multiply even in a vacuum package as low as 31 degrees. So Listeria in particular is the reason why date marking for safety is absolutely essential, and it is required for all time temperature control for safety ready to eat foods. That is a safety date mark, consumer discard by. The next of the 6 conditions is oxygen. Basically, that means favorable atmosphere. Listeria, E. coli, Salmonella are what we call facultative anaerobes, which means that they prefer an oxygen environment, normal air, but they can also change to multiply more slowly in the absence of oxygen. So that means in a vacuum package. So this is one of the major risk concerns that we have to address in ROP packaging. We need to make absolutely sure we are providing the proper temperature control as well as date mark control for that reason. And then the last of these 6 requirements is moisture, basically free water content that is sufficient to support bacterial growth. It's not total water content, it's the water that is available to support bacterial growth, not the water that is bound in chemical structures. So when we're talking about special processes, more so other processes, not so much ROP, but we potentially may change one of these factors to be outside of what the food code requires. So this would require variance. Examples would be canning or fermenting foods, curing meats. So once again, we are changing one or more requirements of the food code to be something else, but that some other control must provide a level of safety that is at least equivalent to what the food code controls would provide if we just simply follow the food code requirements. When we do these other special processes, though, we're going to be using a combination of 2 or more factors, such as high bacterial load, or modifying the pH or the water activity in combination with refrigeration and date marking to keep the product safe. So this is an example of how those different what we call hurdles work together. In this example, if we wanted to vacuum package deli meat, this is a cooked, ready to eat, time temperature control for safety food. Because it has been cooked, we do not have the benefit of a high competing bacterial population that we would have in a raw food. So what we're left with is we're removing the oxygen that limits the growth of pathogens like E. coli, Salmonella, Listeria, Shigella, and so on. That limits their growth. But then we refrigerate the product, your second slice here. E. coli, Salmonella, Shigella, Staph, they cannot grow under proper refrigeration. They all require temperatures between 45 and 50 degrees at the minimum to be able to multiply. And then the next slice, date marking, no more than 7 days for that ready-to-eat product. So there's your third slice. When we have all these necessary controls in place, then we provide an effective system of control measures that will keep the product safe. So when it comes to raw products, raw meat, TCS product not ready to eat, we're allowed up to 30 days storage because of the fact that that vacuum package does prevent the growth of spoilage bacteria. I like to refer to the differences between different pathogens as far as their preferences for temperature and salt content. Those things, I like to refer to that as bacterial personalities. Some of these bacteria, like Listeria, prefer colder temperatures. Others prefer warmer temperatures. So, for example, Clostridium botulinum requires a air-free environment, no oxygen. It cannot multiply when there is more than 3.5% water phase salt. That's salt dissolved in the available water. And the temperature has to be above 38 degrees for the marine strains or above 45 degrees for the land-based strains of this bacteria in order to multiply and produce toxin. Whereas E. coli, the pathogenic E. coli, prefers normal air, but it can also grow more slowly in a vacuum package at up to 7% salt. It requires at least 45 degrees, but the ideal range is from 95 to 115 degrees Fahrenheit, and it can multiply it up to 121 degrees. Listeria also prefers a normal air environment, but it can also tolerate that vacuum package environment and up to about 10 to 12% salt. It must have at least 31 degrees to be able to multiply. It can grow slowly under refrigeration and faster up to about 95 degrees. So the big important thing to remember here is that when we control the most difficult pathogens, then we also control the others by default. Reduced oxygen packaging processes are two primary hazards that we must control are Listeria monocytogenes and Clostridium botulinum. When we control those, we'll be controlling the others. So another important point here, acidity is one characteristic that we can control in some foods. We're doing quick pickling in a vacuum package. That acidic pH can help limit or prevent the growth of some pathogens, but if we rely on that acidity, then we're going to have to address that with a variance in your process because of the fact we're modifying the pH of the food. However, all foods have a natural pH, so the regulation food code does allow for vacuum packaging of foods, whether they're acidic or not, provided you have other factors that are also providing safety controls. I need to point out, though, that acidic pH alone is not sufficient to kill pathogens. So as an example of that, in 1997, I believe it was, there was an outbreak of E. coli 0157H7 from unpasteurized apple juice, which has a pH of about 3.7 or 3.8. There were 65 cases, including one child that died. The natural pH of those apples is, again, between 3.5 and 4. So that's about pH. Here, I'm not going to play this video because we tend to have some issues with it from time to time, but basically what I want to do, I see we have a question. What can I help with there?
Joe Turner asked if you could go over modifying the pH, meaning that they have to have a variance, and if you can explain the reason.
Okay. So the reason for the variance is because we are modifying the characteristics of the food. We're not going to be strictly just following the reduced oxygen packaging requirements in 350.212. Now, if we're going to rely on pH control, then we move to 350.211C, which is the requirement for processes that use acidification or the use of additives to preserve a food, which means extending the shelf life beyond 7 days for that TCS ready-to-eat food, or making it shelf stable, or both. Now what we're doing is preserving a food, which requires a variance and an approved HACCP plan. So because of the fact we're now replacing the normal ROP requirements with pH control, where we have to check the pH of each batch, document that pH, we're using it to extend the shelf life or make the product shelf stable or both. That is what requires a variance. Does that help?
Another question, same person. So a soy beef product can be held longer than 7 days with an approved variance, question mark. And then Brett Warner said, would an example be kimchi for the modifying the pH?
Correct. Kimchi definitely is a preserved food. You're modifying the pH in order to create not only that unique flavor, but also if it's properly fermented, the pH should be below 4.2, which allows it to be, although it's likely to be held refrigerated anyway, to stop the fermentation process. The shelf life could be much longer than 7 days. What was the first question, Kim?
A soy beef product, can it be held longer than 7 days with an approved variance?
So there's two ways that that could be done. Usually what we see is that if the product is cooked, properly cooled to 41 degrees or lower, but then immediately frozen, it could be held frozen indefinitely in terms of safety. Quality might suffer, but it can be held indefinitely for safety reasons. But once it has come out of the freezer, now we have to start the clock. Day one was the day it was packaged and cooked. When it comes out of the freezer, we now have 6 days left, including the day that it comes out of the freezer. So let's say today is the day it's coming out of the freezer. We have 5 additional days. Okay. So the other way is if you, and we've only seen this here in South Carolina once, where an additive, a pair of additives was actually being used to extend the shelf life to 14 days. That requires a variance because, once again, 350.211C in the food code requires a variance for the use of additives to preserve a food, extending that shelf life beyond 7 days for that ready-to-eat food. So they provided a challenge study to show that that preservative system did indeed prevent the growth of Listeria monocytogenes, as well as preventing the growth and toxin formation by Clostridium botulinum. That would be the other way that shelf life could be extended. So that basically those two options. Otherwise, it is 7 days. That is a hard stop.
Okay, she said understood. Thank you. Autumn Woods asked, would a shelf-stable ground nut butter require a variance if the firm already has a HACCP plan?
If they already have a HACCP plan, we certainly would want to review it. So nut butters, nuts are typically associated with E. coli and salmonella as potential contaminants. We would want to know that the process has been validated for production of the nut butter. Obviously, very glaring examples in 2007 and 2008, 2 major outbreaks of salmonella from peanut butter. Between the two, more than 1,200 people were sickened. But if this product is being produced Here in South Carolina, we would, if they're producing wholesale, they would have to have a safety plan. But if they were also going to sell retail, we would need to review that safety plan as well to make sure that they have the necessary pieces in place that are required under the food code as opposed to the wholesale regulations, because the two are different. So we would need to review that plan. Does
We have
that,
another question.
okay?
Has a plan required for dry aging fish, or can it not be done?
Ooh, great question. Dry aging of fish is a process that's becoming very popular. We have encountered that several times here in South Carolina, and I'm aware of that being a national trend. There is no published guidance right now for safely conducting that process. Of particular concern is if we're talking about a product like mahi-mahi or tuna, um, scombroid toxin formation is a particular concern if there's temperature abuse. So the question that comes up, if it's properly refrigerated and it is used within the normal shelf life of fresh fish, about 7 days maybe, there should not be any risk from that toxin formation. However, if that fish is aged for 2 weeks, 3 weeks, 4 weeks, I've even seen 6 weeks, we don't know whether there is a risk there with that fish being held at 38 degrees or lower for that toxin formation to occur more slowly. So we here at SCDA are actually involved in a research project that is being headed up by Purdue University, NC State, and Virginia Tech are also involved. The New York Department of Agriculture, Trade, and Commerce is also a partner in this research. We are hoping to develop guidance to be hopefully initially released later this year to try to develop some safety guidelines for dry aging of fish. But right now, I don't have a good answer for you on that. Wet aging basically would be in a vacuum package, but it should be not a reduced oxygen package, but it should be a 10K OTR bag, which is one that allows a high oxygen transmission rate. So wet aging could be done. That would require a variance, but because it's raw, TCS food, there's not a date mark requirement as a raw food unless that product will be served raw. I hope that makes sense. TCS ready to eat foods have the requirement for a date mark of 7 days or less, but if it's a TCS food that will not be served raw, then there's not a date mark requirement, but it would require variance because of using that 10K OTR bag. Again, for wet aging, not dry aging. So I hope that answers the question as well as we can. So I'm super excited about that research, though. Louisiana State University is also involved in that research. So we're super excited about working to develop some guidance for that process. Great questions. Any others? Okay. So I'm not going to play this video. We've had some issues, but basically, what this does, it illustrates the concept of water activity. The jar on the left is just glass marbles. We placed 20 ounces of colored water into that jar and then pour it off, and we recover essentially 20 ounces of water back because those marbles will not absorb the water. The jar on the right contains starch packing pellets. As we know, starch is a thickener, which means basically it absorbs water. It binds that water in the chemical structure of the starch. So if you added that same 20 ounces of water into the jar with the starch pellets, some of that water would be absorbed and you would not recover that water when you pour off the remaining water. As it turns out, when we did this experiment, we recovered only 16 ounces out of 20 ounces from the starch jar. So when you do the math, 16 divided by 20 is 80%. It's 0.8. So 0.8 would be the water activity of those starch pellets. So that's the difference between free water, which you see in the jar on the left, versus bound water, which would be the the water activity, which would be the water that is unbound by the starch. So when we talk about bacterial growth and shelf life, this is a typical bacterial growth curve. You have the lag phase in which bacteria are becoming accustomed to their environment. If they have been injured by or stressed by incomplete sanitation, they will take some time to heal and recover. But then once they have recovered, they're accustomed to their environment, then they begin what we call the log phase of growth, where basically it becomes exponential growth going up. Bacterial populations can then increase, doubling in as little as 20 minutes. Every 20 minutes, the population would double. Then we get the stationary phase, where the death rate equals the multiplication rate. And then the death phase is where the death rate is exceeding the multiplication rate. So if and a lot of times this could be associated with depleting the food supply. When we extend the shelf life, though, what we're doing is pushing that lag phase to the right by use of preservatives or other hurdles in the process, such as the sliced cheese example I showed you a few minutes ago, where we modify the water activity or the pH, or we use reduced oxygen packaging. Those types of factors, what we're doing is pushing that lag phase to the right to extend that lag phase before bacterial growth is likely to take off. So when we determine a shelf life value, we cut that shelf life off at the point where we start to see growth. For Listeria, we would need to see no more than 1 log of growth, a 10-fold growth. For bacteria like staph, we would need to see no more than 3 logs of growth, because that's where you start to see toxin formation. Same thing for Bacillus cereus. That's that toxin formation, so it'd be a 3-log cutoff for the shelf life extension. Any questions about that? Again, I want to emphasize what preservation is. It is preparing, processing, or packaging a food in a way that makes it less likely to support bacterial growth. In plain English, what that means is we're extending the shelf life of a time temperature control for safety food beyond its normal 7-day shelf life in a ready-to-eat food, or we're making that food shelf stable, or both. Could be either or both of those. So that is what preserving a food is all about. So reduced oxygen packaging methods are considered a preservation method because we're removing air so that raw food will not suffer from spoilage bacteria as quickly. Chemical hazards. Before I jump into this one, do we have any other questions about the biological hazards?
None so far.
Okay. So in your Appendix 1 resource bundle, resources 5 and 6 address chemical hazards. Starting with biological toxins, obviously botulinum toxin is one that is produced by Clostridium botulinum. Staph enterotoxin, same thing. There are several types of shellfish toxins, paralytic shellfish poisoning, amnesic shellfish poisoning. There's a couple of others. Ciguatera is another one that is associated with reef fish, such as snappers and large groupers. That is sourced by fish that have been consuming algae that produce that toxin in the reef. Mycotoxins, that's mold toxins. So examples would be aflatoxin, ochratoxin, and so on. Patulin is another example of a mycotoxin that is associated with spoiling apples. Histamine and scombroid toxin are associated with fish species like tuna, mahi-mahi, mackerel, bluefish. And that forms as a result of temperature abuse at any point from the time when the fish is caught to potentially even improper storage in your restaurant. So we have to maintain temperature control at all points in the cold chain for those species especially. The number one cause of food recalls, anybody want to guess? Drop it in the chat.
They're saying allergens, labeling. Yeah, undeclared allergens and labeling.
Perfect. That is exactly correct. Mislabeling often involves undeclared allergens. Perfect example, if you are used to using Worcestershire sauce from supplier A and it contains no anchovy, which typically it does, but if it contains no anchovy, but then for some reason you can't get it from that supplier, you get it from a different supplier, and that product, supplier B, has anchovy in it, very, very important to read those labels when your supplier changes or if you change an ingredient for some reason. Very important to review that label to see if you're dealing with a potential allergen concern that you would need to address with how you label product if you're packaging it to sell. You would also need to be aware in your kitchen that if you're serving a patron who may be allergic to fish, you as a manager would need to be aware of that potential allergen concern. So watch those ingredients. Chemical hazards can result from failure to follow proper cleaning and sanitizing procedures, potentially after maintenance or repairs of equipment, or after disposing of a product that has been recalled for a contamination issue, such as a mislabeling issue. Unapproved sources of food ingredients can also result in a potential chemical hazard. Same thing with inappropriate or unlicensed use of pest control chemicals. We've seen a few issues like that. I've seen some pictures from some of our inspectors that had to do with that. The use of unapproved food additives or the improper use of approved food additives. The example I always pick on there is the improper use of nitrate or nitrite in cured meats because of the fact that can pose a serious health hazard. The regulatory limits are based on health safety limits and on serving sizes, the method of cooking. But we have seen some curing recipes that had as much as 20 times the legal limit of nitrite. So that's a perfect example of where an approved additive was misused and can result in a chemical hazard. Questions about chemical hazards? Any comments?
Not in regard to chemical hazards. There is a question though. So the point of using REP for sous vide isn't about preservation because it doesn't extend life of the product. It's only held for 7 days, correct?
That is correct. That is correct. Although FDA does, on a consumer web page, FDA does advise a shelf life of no more than about 4 days for products held by consumers. So in a sense, it sort of is a bit of a preservation process, but really sous vide cooking is more about the quality of the product that is produced. It's cooked in its own juices rather than by some other method that could result in a more dry consistency, maybe some other characteristics. So it's really more about the quality of the product that's being produced, and potentially even infusion of the flavors of the seasonings that are included with the product. Any other comments or questions?
Jeffrey, you started to ask your question, but you didn't type it all the way. So if you can finish your statement, we'll be able to answer it.
Okay.
Josh asked, in the case of commercial salami, if I open the package and REP 2 smaller portions and label it with the date, with that date, how long can I hold that product as it is preserved?
Okay, so there's two pieces to the question. So if it's a salami, I'm going to assume that it is probably cured as well as having been fermented. Being cured means, in terms of FDA's perspective, that nitrite was used. Salamis typically are cured products, and of course they are fermented. So under 3/502.12b, one of the characteristics of foods that are allowed to be vacuum packaged is that they are cured in a manner that is in compliance with Title IX CFR Part 424.21. That is the USDA HACCP regulations. The particular citation has to do with curing. So if it was produced at wholesale, it should have been produced in compliance with that regulation under USDA or state inspection. If it Here in South Carolina, our perspective is that if we have reviewed and approved a curing and fermentation process for producing salamis, and that process is in compliance with that same USDA regulation, then we will consider that equivalent to the product having been produced under USDA inspection. So 3/502.12b allows those products to be ROP packaged for up to 30 days. The qualification I need to put on that is if that commercial product has less than 30 days remaining on the shelf life assigned by the producer, then you cannot give it 30 days. Once you break that salami down and you repackage it, if it only has 20 days left, then you cannot put more than 20 days on the shelf life of the broken down product that you have repackaged. Good question. Thank you.
We have another question.
Okay.
Can seafood be ROP'd? I know that for fish, it must be frozen during every step of the process, but what about lobster tails or scallops?
Okay, so lobster tails and scallops, the definition of fish includes fin fish, shellfish, crustacean shellfish, mollusks, molluscan shellfish. Mollusks include octopus, squid, lobster, all of those are included. If it lives in the water even part-time, like frog legs, that is considered fish in terms of the food code. Alligator, same thing. It's considered fish in terms of the food code. So yes, fish can be packaged in ROP, but they must be frozen, like you mentioned, before they're packaged. So the basic simple guidance would be portion it, package it, or excuse me, portion it, freeze it, then package it, keep it frozen, and then remove it from the package when it comes out of the freezer to be thawed. Okay, good questions. Thank you. Any other questions?
Tim Waters asked if you could repeat your answer in regard to the lobster tails and scallops.
Yeah, so again, we have to refer to the definition of fish in the food code. It includes fin fish, shellfish, molluscan shellfish, crustaceans. That covers lobster, crawfish, any kind of shellfish, mussels, clams, oysters. All of those are fish in terms of the regulations. So if you're going to ROP any of that, alligator bites, crawfish, if you're going to vacuum package any of those products, they must be frozen before they're packaged. And they must be kept frozen while they're in that standard ROP bag. They can be packaged in 10K OTR bags because they allow a high rate of oxygen transmission through that film, but that product is only approved for raw fish with no other ingredients. It cannot be used for sous vide cooking. It cannot be used for storage of cooked fish because of potentially other ingredients and the fact that it is only approved for raw fish products. Does that help?
All right, so we have a few more.
Okay.
Is that also called flash freeze for fish?
Flash freezing, basically, that would be, if you put the product into a blast freezer or cryogenic freezing. But that's not the same thing as the 10K OTR bag. That is a specific type of bag that allows a high rate of oxygen transmission, 10,000 cubic centimeters per trying to remember the exact units. It's 10,000 cubic centimeters of oxygen per uh, meter of the plastic film per 24 hours or something like that. I don't remember the exact units, but it's a lot of oxygen. So that has basically it has to do with the oxygen transmission rate of the film. Standard ROP bags allow almost no oxygen into the bag whatsoever. They're very, very low. So that's the difference. Does that help?
Um, Someone asked, so when fish comes in, it must be frozen based off your comment regarding the RP freezing.
Right. Again, so if you're receiving fresh fish and you want to ROP it, best advice would be to portion it into steaks or fillets, freeze it, and then package it. That it must be kept frozen while it's in the bag, removed from the bag before thawing. Okay. Any other?
Um,
Go ahead.
Tim, for clarity, when you say what type of bag must be used, are you talking about the 10 KOTR or are you talking about the ROP bags for frozen fish?
Uh, Fish do not have to be frozen before they're packaged in 10K OTR bags because of the fact that it allows basically air into the package. It is just really a convenience packaging to save space or whatever. It allows you to store the fish fresh, not frozen. Standard ROP bags with the low oxygen transmission rate, those are the ones that require the fish to be frozen before it is packaged. Okay.
Amelia asked, soybean for fish cannot be approved, question mark, fish must be frozen before, during, and after packaging per code.
Okay, so right now the food code, the way most folks are interpreting that, fish could not be cooked sous vide. However, there is science that supports it. It would require a variance. I plan to submit an issue on this to the Conference for Food Protection this year to hopefully get some, the ROP section there, 350-212 is a hot mess. I'll just be honest. But I'll be submitting an issue this year to the Conference for Food Protection to hopefully get some clarification on that. Yes. And we have the validation that I wrote up with help from Rutgers University and NC State University. So if someone does want to sous vide fish, we have a number of folks in South Carolina doing that. We provide the validation as part of your HACCP plan. So that's just something to have a conversation with your inspector, have a conversation with Kim or myself, and we can provide that guidance. It would require some modification of the HACCP template, but yes, it can be done, but it does require a variance, and we provide the validation for that. And I know Kim loves doing HACCP plans with octopus. I'll just
So Cheryl, for freezing, you can use any RP bag when it comes to fish, but for if you're going to keep it refrigerated, it's a 10K OTR. I put a screenshot above your comment that clarifies what kind of bag is used for fish.
Okay, perfect. Perfect. Okay. Any other questions before we move along?
No, but Brett made a comment saying the bag must be cut open once removed from the freezer regarding fish, which is correct.
Right. Good. Okay. Physical hazards. Any object that can cause a physical injury. Where can these come from in your process? Drop some suggestions in the chat. Think about scenarios like if you receive roasts and you cut those roasts into steaks. If you're grinding meat to be ROP packaged.
All right, we have equipment, kitchen utensils, cutting board during fabrication, improperly deboned meat, plastic from cutting boards, metal fragments from slicers, the blade and parts of the machine. There is a question, I don't know if this is state regulated, for this individual, it says that fish has to be removed completely from the bag.
So at the Conference for Food Protection last year, this was an answer that frustrated a lot of us because FDA was presented that exact question. And the way they responded was basically, well, we think there's a possibility of pockets of reduced oxygen in the bag if you just slice the bag open. So we really want you to remove it from the bag. And they were challenged on that. I was like, can you show us the science? And the response was, we just want you to remove it from the bag. So it's up to the really, it comes down to the policy of your local jurisdiction as to how that needs to be handled. We're kind of questioning that here in South Carolina as far as pockets of reduced oxygen. We want to see the science. Bottom line is open the bag all the way, or to be much safer, go ahead and just remove the fish from the bag. You could do either one, and we would accept that. But it is not sufficient to just poke a hole in the bag. Cut it all the way open or remove the fish from the bag. Right. So those were some good examples of where those physical hazards could come from. I'll give a quick example. In my previous work in a laboratory, I had one customer who would submit samples of deboned meat, cut up meat from a chicken plant to be tested for bone residue. And what we found in working with that customer was that when the bone residue percentage in the meat increased to a certain point, by comparing that to the condition of the boning saws, they were able to make a correlation to show that at some point, at some certain level of bone residue, that meant that the blades needed to be replaced. So there is a correlation there, and so yeah, you want to absolutely pay attention to the condition of those blades, the condition of the equipment, loose screws, things like that, because if it gets into a product you're producing, like a sausage, for example, especially, even if it's just a fresh sausage, you get a screw in there, someone's going to bite it before they realize that it's there, and then you have a physical injury. So bone fragments, foreign objects, things of that nature, physical hazards. Very good.
We have another question.
Okay, go ahead.
I don't want to mispronounce the name, so I'm not going to state it, but they asked if you want to use the fish for sushi and you want to freeze for parasites prior to RP, could you talk about what should be done?
Okay, in the food code, section 340211 requires proper freezing. There are three options given there for proper freezing temperature and time. So you would need to follow those requirements. Just pick one temperature and time combination. 340212 requires record keeping. So you must keep a record for each batch of fish that you are freezing for parasite destruction to show that you have met the time and temperature requirements. So you can do that, but it does require a written procedure that must be approved. We've only had one or two here in South Carolina, but that certainly is something that you could do in-house if you wanted to. But again, that procedure has to be approved by the regulatory authority. Good question. The other options, though, if you don't want to have to freeze, then would be to source the fish that is produced. One of the other options where it is farm raised and pellet fed with using a parasite-free protocol. That's the other option. There are very few species of fish that are exempt from the parasite concern, basically as large tuna species. All others, though, we have to consider as potential for parasite hazards. And that includes products like shrimp and so on. Okay, any other questions?
Someone said, as far as sous vide for food cooked and chilled, then opened and cooked to order, does that change the process needs for the program?
So if I understand the question correctly, if the product is cooked sous vide and then immediately served, or is that chilled, cold held, and then reheated for service?
I think they're doing sous vide cooking. Oh, they said chilled. Okay.
Okay. The way FDA views sous vide cooking is that it includes not only the cooking step, but also proper chilling, proper cooling, cold storage, and then reheating. It could be reheated either in the bag, or it could be removed from the bag and finished on the grill for grill marks, or some other method of cooking, or final cooking. Okay. Let's do a quick knowledge check. Which of these factors do bacteria require for growth? What is your best answer?
A lot of people saying B.
And B is correct. Very good. So just to kind of get warmed up for HACCP here, basically hazard analysis and critical control points. Simply put, it is just a systematic way of applying specific and science-based controls to address potential significant hazards that may be present in raw food materials, or that may be introduced as a result of one or more elements of the process, and that are reasonably likely to occur. That's the risk factor. And if it does occur, there's a high likelihood of causing illness or injury or death. That's the severity factor. So to determine significance of a potential hazard, we would use the tables, resources 2 and 5 through 7 for your biological, chemical, and physical hazards. And then we would also use the risk and severity matrix, which is resource number 8. There are some other tables out there that do a similar approach to assessing risk and severity, but that table is from NSF, the National Sanitation Foundation, and it is a good chart to use. So what I want to point out at this point is that the tables of hazards are a great resource, but you need to know that the information in those tables, especially the biological hazards, tends to expand over time as we see new significant pathogen and food combinations. Who would have thought a few years ago that we would see major listeria outbreaks from cantaloupes? But we have seen that. 2 years in a row, major outbreaks. Some other examples, cantaloupe, cucumber, and red onion for Salmonella Newport. We have an outbreak right now for jalapeno peppers with Salmonella. So the red onion one, in 2020, there were 1,200 cases of Salmonella Newport just from red onions. So those are not specifically listed in that resource number 2. So, but over time, we have to be aware that those tables can expand. Absolutely important to rely on your regulatory authority to help you with the hazard analysis. In our templates, we provide you with a hazard analysis that is based on what we typically would expect for the typical products going into your process. But we would provide guidance or assistance in modifying if you're doing something different that would require us to modify that hazard analysis. We don't expect you to know it. We do ask you very strongly to work with us to make sure that the hazards are properly addressed. So if you go to that risk severity matrix, resource number 8, I'm going to give you a couple of examples, and I want you to tell me whether the hazard is significant or not significant based on your analysis of the risk. First of all, let's talk about salmonella in chicken. Do we expect salmonella to occur in chicken? And if it does occur, how severe is it likely to be? So would we call this a significant hazard, salmonella in chicken? Let's drop your answers in the chat, please.
Yes, severe. Lots of yeses. Some said bad. Yes, significant.
Okay, good. And yes, that is correct, because we do know to expect salmonella in poultry. It should be at a very low level, but the producer cannot guarantee it is not there. It's just not possible. If it does occur, hospitalization is a significant possibility. In a low percentage of cases, it can result in death. So now let me give you another example. What if I asked you about the possibility of Vibrio in chicken? Would we consider that to be a significant potential hazard? Resource number 2, and then your risk severity matrix.
No. Everyone's saying no. Someone said, what is that?
Vibrio is typically associated with shellfish grown in warm waters, Gulf Coast. We've seen Vibrio cases as far as up the Middle Atlantic, potentially also from the Pacific. Well, basically, it is a warm water, brackish water pathogen that is associated with shellfish, such as oysters. So how could we get Vibrio into that chicken? What are your thoughts?
Contamination, cross contact.
That's exactly right. That's exactly right. So that's where we have to be very, very careful about preventing cross-contamination. That involves especially hand hygiene practices. Okay, good. So this is just a very limited table, but I just put this together just to show you what are the some common controls and critical controls for dealing with these different pathogens. So the ones that are critical are in that kind of reddish color, and then others are in black. So just basic practices and then critical practices. So the concept of a critical control point is that it is the process step at which the identified control measure must be applied to address a specific significant potential hazard. We use that resource number 9, which is a decision tree that is just a cleaned up version of FDA's decision tree that's provided in the food code. So we just ask the questions in sequence to determine whether each particular step is a critical control point step. The concept of a critical limit is that it is an observable value or a characteristic that must be achieved in order to prevent or destroy or reduce a hazard to an acceptable and safe level. That is the limit that divides safe food from potentially unsafe food. I tend to think of a critical control point as the edge of a cliff. And if you go over the edge of the cliff, then you're in serious trouble, right? So we need a guardrail at the edge of the cliff. That is your critical limit. So let's talk about a couple of examples here. Reduced oxygen packaging, raw products, you expect a typically high bacterial load. You're going to use refrigeration and date marking. So you've got 3 different controls there to provide a level of safety, and the refrigeration and date marking are specific critical limits for that packaged product. Another example, this has to do more with a non-shelf stable cured sausage, but we're going to use time and temperature plus salt content, nitrite, and reduced water activity. So that would be for like a semi-dry type of sausage. So I want to make sure we have a very clear understanding of critical control points and critical limits. Health policies, hygiene policies, employee hygiene, sanitation procedures, those are not critical controls because they do not address a specific hazard, and we cannot specifically monitor to determine that we're in compliance with those. Those are preventive measures, but they are not critical controls. Critical control is a specific measure in your process that is used to prevent or eliminate or reduce a hazard to an acceptable and safe level. Are there any questions about that before we move on?
Oh, we have two questions that kind of go back before the statement. She was basically stating if you sous vide if you sous vide for 2 to 4 hours and then grilled, you had no storage and no cooling step. Do you need a variance?
We would, here in South Carolina, we would treat that as a variance because of the fact that, number one, we need to document that you're not following the whole sous vide process, cooking, cooling, cold storage in the vacuum package. You're just removing it from the bag and then finishing it on the grill. But because you are using reduced oxygen packaging, we just need to document that for the sake of your inspectors. Basically, you are at the very least, we would look at 350.212, which allows you to use the process without a HACCP plan, but it's not going to be in the package any longer than 48 hours. Potentially, just depending on your particular jurisdiction's policy, it could also be looked at in using 350.211D of the food code, which basically is controlling Clostridium botulinum and Listeria by means other than as prescribed in 350.212. So basically, you're limiting the time in the vacuum package. You're immediately finishing it on the grill and then serving it. So that would be an alternate method of controlling those hazards, just limiting the time and going straight to a final cook step. Does that make sense?
So, Dora, does that also answer your question? Okay, they said when submitting the variance, does a fish breed make a difference?
Repeat the question, please.
When submitting the variance, does the fish breed make a difference?
Oh, the fish species? No, it does not. If the food code defines the product as fish, regardless of what it is fish. Once again, finfish, shellfish, crustaceans, mollusks, alligator, frog legs, sea cucumbers, all of that is fish in terms of the food code. Species is not differentiated in terms of what is called fish.
Someone said, I noticed you talk about controlling the hazards. Can you go deeper so I can get a better understanding?
So, it's a very general question. So, in ROP packaging, if you're following the requirements in 350.212 to properly refrigerate the product and date mark the product, depending on which, if you're doing storage of raw meats, 30 days, cheeses, 30 days if they are hard or semi-soft cheeses, fish frozen, sous vide cooking and ROP cooked chill, 7 days, all of that's under refrigeration. If you're following those, then you're in safe territory. But if you modify any of those conditions, then you're going to have to provide other controls that provide an equivalent level of safety. But when you're just following 350.212, those are the conditions really that you're going to be controlling as critical. Once again, refrigeration, date marking, properly cooking for the required time at temperature, proper cooling, cold storage. Those would be the controls that you'd be focused on. If you're doing other things like quick pickling, and then storing that product for an extended time, then we get outside of the normal ROP requirements. We're providing other controls. Now we have to be sure that you're providing this an equivalent level of safety to what would be provided by simply following 35012. Does that help?
He said thank you, so I assume yes.
Good. Okay. All right. Any other questions before we move along? We're going to take a break here shortly. So when we create a HACCP plan, I need to emphasize the absolute importance of obtaining training. That's why we have created these workshops. We know that HACCP courses out there in the industry, number one, they cost money. Number two, they cost time. This is a very condensed version. That's why I have told you that it's not for certification, but is to provide some basic instruction on the specific process that you're doing, which would not be covered by the typical commercial HACCP courses or academic courses. So that is essential. In the food code, there's an issue with the fact that it does not specify that you must obtain HACCP training. It only says you must have a plan for training the supervisors and food staff on the food safety issues of concern. Validation is an important concept. It means obtaining scientific evidence that a proposed control measure will effectively control a potential significant hazard. Will it be effective? Validation provides that evidence. If you're following exactly 35012, you don't need to provide any further validation because all of that has been validated for you by FDA. If you use controls that are outside of what is provided in the food code, then you'll have to, that's where we have to talk about providing some other validation resources. A great example, if you want to cook low and slow, let's say you want to cook a beef roast 130 degrees for at least 112 minutes at that internal temperature, that is included in the food code. But if you wanted to cook chicken low and slow, that is no longer included in that alternate table of times and temperatures in the food code. You have to go to an FSIS document. It is the Cooking Guidelines for Meat and Poultry, Appendix A, December 2021. There is a specific chart for chicken and there's a specific chart for turkey. You would have to use the guidelines in one of those two charts. If you don't know the fat content, then you would have to go all the way to the right in the appropriate chart and use that time and temperature combination, such as, Kim, I think you've got the chart right there handy if you want to give an example for the chicken. I'm trying to remember minimum temperature and time.
It is 1:45 for 13 minutes.
Right, good. So that would need to be cited in your HACCP plan as the source for that time and temperature combination because it's outside of the food code. So once again, the controls that are identified in the food code and your local regulations are backed by published and extensive research. Those cooking temperatures, cold holding, date marking of TCS ready to eat food, none of those require further validation if you're following the food code. But when you need a variance is when you go outside of those regulations, food code, that's where it becomes a variance issue. And so there has to be validation provided to support those alternate controls.
We have a few questions.
Okay, go ahead.
Someone said, I had a restaurant that put holes in the bag used for sous vide, and they claimed it was no more sous vide cooking. If you put holes in the bag, is it still considered sous vide cooking? And then someone asked, are they boiling food in a leaky bag? And they said, yes, top of the bag. I said, the bag's supposed to be fully submerged in the water bath as well as an RP bag. But if you want to clarify if they add holes in the bag.
So the term sous vide means without air. So if you poke holes in the bag, you're letting air into the bag. We don't know how much, but it is no longer sous vide technically in terms of the definition of that term. But I also would raise a question about what are you letting into the bag when you poke those holes? What are you letting out of the bag when you poke those holes in the bag? So I would strongly recommend against doing that. That is not a good idea. And that's not a good way to get around the regulation. So again, I would strongly recommend against that for those reasons. If the sous vide bath is not kept in clean and sanitary condition, who knows what's in that water that you're letting into the product. So no, please do not do that.
Someone else said for hazards such as roundworms, is there paperwork that sources can provide to certify that their product is free of them?
Free of what was the term? But
Roundworms.
okay, so that would be a parasite. I'm trying to think. What is the product?
It doesn't say it says for hazards.
Okay, so I'm assuming that that would be a product like pork. If it is from an approved source, USDA inspected farm and processor, there should not be an issue. In 2018, USDA issued some new guidance for trichinella, which admittedly that's not a roundworm, but if the hogs are lot fed and it is a parasite-free certified feeding protocol, then USDA does not consider that trichinella is a significant hazard that is likely in the U.S. domestic pork herd. However, if you are purchasing from a farm that is raising free-range hogs, then now you really have to assess your supplier to determine whether parasites, including trichinella or any other parasites, may be a hazard that has to be controlled by cooking or freezing. So that's what comes to mind on that. Roundworms, we don't tend to hear about that much. But yeah, proper cooking is going to be the proper control for parasites of any sort, roundworms, trichinella, and so on.
All right, there's a few more.
But again, I would refer you to that 2018 trichinella guidance from USDA.
Okay. Someone said I see a lot of pickled onions in ROP with acidification. Do they need a variance for both acidification and ROP?
So there's a couple of questions here. First of all, are they going to control the pH or not? If the pH is not going to be controlled, the best practice would be to, and the appropriate practice would be to treat it as a TCS ready to eat food, date marked 7 days under refrigeration. The reason I say that is because when you look at interaction table B in the definition of TCS foods, onions pH is around, like the high fives, around 6. Water activity is like 0.97. So when you look at that interaction table B, if the pH and water activity combine and it gives you a value that says PA, that means product assessment is required to show that it is not a TCS food. So basically, it is a TCS food until proven otherwise. So that's why I say if they're not controlling the pH, you don't know what the pH of the onions will be. So you need to refrigerate and date mark 7 days or less. However, if you're going to control the pH by making one test bag and pouring off the brine, take only the onions and properly prepare those, test the pH to make sure that the pH is less than 4.2, then you could extend the shelf life to wherever you want because now it is a non-TCS food. Still, you would probably want to keep it refrigerated just for the crunchiness and all that. But you could extend the shelf life with a variance based on pH control. So you would have to have those pH records as part of your plan. Procedures for testing, calibration of the pH meter, and then the actual pH monitoring for the batches. Good questions. Love this discussion.
There's more.
Okay.
Mike, I'm currently answering you. Tim asked, do you have the water coming out of the tap tested and how often? I'm guessing this is for soybean. Do you have to have the water tested if it's coming out of the tap?
I would refer you to your local regulations on that. If you're, if you're on a public domestic water supply, you can get a water quality report from the utility. Um, but if you're using the water as an ingredient, beyond that, we in South Carolina would not have a requirement for any additional testing on your part. I can't speak for any other jurisdictions though. But if you're on a well, I will say that if you are operating on a well and you're in a restaurant, I know the way South Carolina's regulations work is that if that water is providing, if that well is used to provide water for at least 8 people, then it is a public water supply. So in that case, you would fall under public drinking water regulations. And in that case, yes, you would have to have the water tested. And I would defer to whatever the requirements are for your local Department of Environmental Services or Department of Health, whoever in your state regulates public water, you would have to go by those guidelines. Good question. Okay. Any others before you move along?
Someone said, if you poke a hole in the bag and then clip to the side outside of the water, technically you can cook with a small hole.
But the definition of sous vide once again means without air. If you've poked a hole in the bag, even if you're keeping that hole above the water, technically it's not sous vide cooking. Sous vide means without air. So if you let air in, it is not sous vide per se. Okay. So we are close to a point where we need to take a break. Let me just tackle this real quickly. So when you create a HACCP plan, it needs to be specific to your facility, to your process. You cannot lift somebody's plan from a buddy over, in another state or another restaurant. It has to be specific to your facility, your procedures, your process, your products. It needs to cover every step of your process from receiving to sale or service, or ending before the preparation of a recipe in which the finished product may be used. For example, if you're sous videing chicken to be used in making chicken salad, preparing that salad is not part of the HACCP process. So it would just be the final product of that HACCP process that we're concerned with, not a subsequent product. But you need to understand, though, once you have written the plan, gotten it approved, it is basically a contract with the regulatory authority. You are contracting with the regulators to follow that process exactly. It expresses your commitment to follow that plan exactly as written and approved. You can write a plan to produce multiple products if they follow the same process. But once again, HACCP always is one step backwards to one step forwards. So from receiving to sale or service. Let's go ahead and take a break right here.
We have 2 questions real quick.
Okay.
Brett said cold pickle 7 days. Hot doesn't need a HACCP plan. Another one said cold pickles do not need a HACCP ? Hot pickling needs a HACCP.
Hot pickling definitely needs a HACCP plan. However, that is regulated by your state. Cold pickling, if it is a product that we would consider non-TCS, it's hard to answer this question because different states look at this differently. But if that produce is cut before it is pickled, then it really should be treated according to Interaction Table B, considering that product to be TCS. So pH control and refrigeration should be required. if you're going to extend that shelf life. Otherwise, treat it as a TCS ready-to-eat food. And that's, unfortunately, that's the best answer I can give you because different states may look at it a little bit differently. Okay. Any other questions? A lot of great discussion this morning. Thank you. Okay, let's take a break. Let's get back together at 5 minutes till the hour. So that would be 5 minutes till 11 Eastern time. And do we have anybody from west of the Mississippi? Just, drop a yes or something in the chat. In what state? Just curious. Okay, let's take a break. We'll come back at 5 minutes till the hour, and we will get this thing wrapped up by about 1 o'clock. Welcome back, everybody. Thank you for the great discussion. We will be making this recorded session available. We will be recording this week as well as next Monday, and we'll make both recordings available to you in a final email. So you'll have those. It's a cloud recording, so it'll be there permanently through Food Shield. You can also find the recordings if you go to our SCDA ROP workshops group in Food Shield for those of you that are regulators. So we're more than happy to share those recordings with you. So let's jump back in here. Prerequisite programs basically are policies and procedures that provide a solid foundation for your HACCP plan. Health policy, employee hygiene practices policy, sanitation procedures, thermometer calibration. These do not directly impact the potential hazards necessarily in your practice. You don't have a way to specifically measure the effectiveness of these policies and procedures, but nevertheless, they provide effective preventive control in your process to prevent the likelihood of a failure that could happen if you didn't have these policies in place. The best written policies and procedures are worthless, for example, if you don't have a plan to train your staff. So especially very important to consider that, the importance of having those prerequisite policies and procedures in place to support the effectiveness of your HACCP plan. So this is kind of an example of what a food safety management system would look like. At the very bottom, you would have good retail practices. Is your facility designed properly? Do you have appropriately designed equipment that facilitates cleaning and sanitizing? Preventive controls would be things like pest control. If you have a policy that only employees are allowed in the kitchen, no one else is allowed in the kitchen, it's a preventive control. Then we move up the pyramid here, and now we have employee health and hygiene policies, which are essential, as well as sanitation procedures, which are essential, and then training, absolute necessary, and it is required in 8-201-14 of the food code. So without that training on the policies and procedures in your HACCP plan, then you have a weak HACCP system. HACCP itself is right at the very top. So if you don't have these policies and procedures in place, then potentially what happens is the whole thing can fall apart, and then you have a greater risk for causing an outbreak or causing illness or injury to your customers. So at that point, the risk to your facility as well as to your customers is also much greater. So for this reason, we required employee health and hygiene policies as part of your HACCP plan. As I mentioned earlier, if you're cooking low and slow, such as in a sous vide process, it is absolutely essential to have those health and hygiene policies in place as well as sanitation procedures to protect that product, even though it has not yet been cooked. Because that cooking step, remember, once again, those cooking steps are based on destruction of bacterial pathogens and not viruses. Absolutely essential to remember that. So when a critical failure occurs, your customers will be the first people to know that because of the resulting illness or injury. And then by the time you find out, there's going to be an avalanche of negative consequences to your business because your system has failed. The primary goal of HACCP is to proactively prevent those failures, but by properly maintaining your records, it also provides a proven process for maintaining proactive control and identifying weaknesses in your process, and then thereby implementing process improvements, hopefully before a failure occurs that would result in illness or injury. So your prerequisite programs at the minimum would include employee health and hygiene practices. Again, the template that we provided to you includes model policies for health and hygiene practices, basically summarizing the requirements in Chapter 2 of the FDA Food Code. There are other types of programs that could be included, but we do not require those here in South Carolina. Things such as how you would manage your equipment. How are you going to maintain your equipment to prevent physical hazards? In that case, we just ask you to include in your sanitation procedure that the equipment will be inspected as it is reassembled for use after it's been cleaned and sanitized and air dried. So examining, just making sure it's in good repair before you go to slicing steaks or grinding meat, for example. We are focused most heavily on those policies and procedures that most directly relate to your HACCP process. We'll be discussing each of those policies and procedures in more detail next week. Kim will be covering that for you. The most basic prerequisite programs include employee health and hygiene policies, your sanitation procedures, and just absolutely essential to pay close attention to effective cleaning of those niches, cracks, and crevices. Tiny places that can hold food residue, because that is where trouble gets started. It's not the places that are easiest to clean, it's the places that are hardest to clean that will eventually result in contamination issues if you don't focus on those. When we talk about biofilm, a good way to think about that is the plaque on your teeth that the dentist has to scrape away. That is a biofilm. The pink discoloration you can see on the water lines in your ice machine, that is a biofilm. And as far as bacteria are concerned, that is food. They're indiscriminate as far as what they consider food. That is a biofilm. So your sanitation procedure can address inspection of the equipment before it is used to make sure you're preventing potential foreign material hazards. And it should include that if necessary. Calibrating critical instruments such as pH meters, thermometers. Thermometer calibration is specifically required in Chapter 4 of the Food Code. But pH meters, if you're using a sensitive scale for weighing curing salt, that also needs to be calibrated properly on each day of use, because it is used to monitor a critical limit. Same thing with a pH meter. Prerequisite programs also would include having written instructions to the process, detailed instructions that an employee could follow and do the process correctly. So when you write the CCP summary table or the HACCP summary table, that is not a complete set of instructions. That only summarizes the actual critical limits, how they will be monitored, and corrective actions, verification. But your procedure section, part 4 of the template, provides the detailed instructions for every step of the process, so an employee should be able to follow what you wrote and do the process correctly. Your training plan should cover what will be covered in the training, who will be trained and for what reasons, when the training will occur. And when I say for what reasons, give you an example. If the first person comes in on Monday morning, they find that the main cooler has gone out of temperature, it's 47 degrees, and they don't do anything about it. They just go about their business. Everybody else is reporting for work, starting to prepare food and so on. Does that issue require retraining? What are your thoughts? Absolutely. It does require retraining because they did not do the correct thing. If that employee had instead gone straight to management and said, hey, main cooler's out, we got to do something different, they reported it to management and they took the corrective action. They took the actions to do what they have to do with the food as well as to get it repaired. That is not a retraining issue. Yes, it does require corrective action, but it does not necessarily require retraining. So if there's human error involved in a failure to meet a critical limit, that is where retraining must be part of a corrective action process. And then HACCP plan maintenance. We require that. It's not specified in the food code, but it is required as part of Principle 6 of HACCP. And we'll get to that here shortly. Validation and verification, HACCP plan maintenance, or reassessment, annual reassessment is what it's called in HACCP language. Basically, keeping the plan current with process changes, updates to the regulations, if you need to make changes in your process, or procedure or policy improvements based on review of corrective actions. That review of corrective actions is an essential piece of that HACCP plan maintenance because that is where your opportunity is for addressing issues that keep coming up over and over. The other piece of HACCP plan maintenance that's really important, we have seen this a number of times where some of the HACCP team does not feel the procedure is working correctly, so they pencil in a change, and then that's what they do instead of what was written and approved. That invalidates the HACCP plan. So the model policy we've given you in your template for maintaining the plan includes what is your process by which, if someone thinks there's an issue with the procedure, they need to report that to whoever is your HACCP team lead, whatever you call that person, so that that person who's responsible for writing and implementing the plan can look at that issue and determine, is this something that requires retraining? Is this an issue that needs to have, do we need to modify the procedure or modify the policy? You cannot allow for ad hoc or random changes to the plan. If you need to make changes to the plan, you need to get in touch with your regulatory authority through your inspector, or here in South Carolina, you could contact myself or Kim Messick, and we will guide you through whatever issues you're going to need to focus on to revise your plan and get it reapproved. You cannot just you cannot work with an invalid HACCP plan. That is not allowed. So making changes without getting them approved puts you in that situation where you'll be marked out of compliance. So all of these policies and procedures that I just mentioned directly support the effectiveness of all HACCP plans. Are there any questions about the prerequisite programs? Okay, all right. Knowledge check. Which of these sources can result in contaminated food? Best answer.
Everyone's saying F.
Absolutely. Very good. Good, good, good. Next question. Which of the following is not true about a HACCP plan?
Everyone's saying D. Yeah.
And that is correct. Very good. Okay. So we've talked about the economic cost of foodborne illness to consumers and to your business. I'm not going to play this video once again, I guess really for the sake of time at this point. We've had a lot of great discussion, but the point is there is a human cost to foodborne illness, and we do not want to be, and you do not want to be a part of causing a foodborne illness outbreak. The consequences are catastrophic for consumers and potentially for your business. So please, please, please take responsibility for the HACCP plan, own it, and make sure you provide proper and regular training to reinforce the importance to all your staff, your HACCP team, of following the plan as written without changes. I see a question there. Can we send a link for the video? We have provided you with a PDF of this presentation as well as the presentation for next week. I believe that link works. We'll double check that just to make sure, but yeah, that link should work. We will verify that. So we just took a break a few minutes ago. Preliminary steps of HACCP. These are the steps you need to do before you can actually write the HACCP plan. Number one, who is going to be doing the process? If you have, what was that? If you have several people that will be using the particular process, they all need to be trained. Think about, for example, if you have a restaurant group, 4 restaurants, let's say, one of those does all your ROP packaging or all of your sous vide cooking, and then the product is shared between that location and 3 others under the same ownership. Someone has to be responsible at those B, C, and D locations for maintaining proper temperature control and date mark control. They have to be part of the HACCP team. It is not just the person who wrote the plan and the executive sous chef. It is everybody who will have any part in the HACCP process, whether it's actually packaging the product or just receiving it to be sold from a sister location. We have to consider all the ingredients, not just the proteins. Keep in mind that packaging is also considered an ingredient. So you want to make sure that if you need flexibility in your menu, for example, you can build that into the process. For example, you can say various cuts of whole muscle beef and ground beef. Differentiate between whole muscle products, though, and products that are not intact meat. So you could say various cuts of whole muscle beef, pork, and lamb. Next line, ground beef and mechanically tenderized pork, for example. Why is that important? Because if it is whole muscle, the cooking requirement for those whole muscle beef, pork, lamb products is 145 for 15 seconds. Whereas those ground or non-intact, mechanically tenderized or injected products, it's 155 for 17 seconds by the 2022 food code. So different temperature requirements for cooking. That's why they need to be differentiated between whole muscle and non-intact muscle. The intended consumer. Will the product only be served in-house, or will you be selling products in vacuum packaging to consumers for home use? This affects the labeling requirements, because now you are handing control of the cooking step and cold storage to the consumer. So you need to provide that information to the consumer on the label. That's critical information. You will not be in control of it. You need to provide that information on the label. So let's see. So distribution to satellite locations of the same business. Catering, those are also considerations for how the product will be stored, how it will be distributed, potentially labeling requirements. Will you be catering? So you've got to think about all of those different issues in describing your intended consumer. Labeling requirements, some basic consumer handling instructions for storage and preparation, or are there allergens that may be of concern? If you sell a product in a marinade, what are the ingredients of that marinade? They need to be declared on the label. If that product is packaged for sale to the consumer, that information must be provided per 360211 of the food code. The flow diagram is necessary, whether you use blocks and arrows or a line list of steps, but the importance of that is to visualize the process, including minor variations that may be used for some products, but not all. The importance is to consider the activities and the equipment that are part of the process, because those activities and equipment can potentially contribute to a potential hazard. So it's absolutely important to think through those details, and not just what are the steps, but how do we get from one step to the next. HACCP is all about controlling the process. And so you can't completely control the process without looking at every aspect of the process. It is possible to write your plan for multiple products that all follow the same process. So you, like I mentioned a minute ago, you could have a sous vide plan for whole muscle beef, pork, lamb, and chicken, but all following the same process. There will just be different critical limits for the cooking step. So once the flow diagram has been created and we've done the hazard analysis, then we need to go back to the flow diagram and mark on there which steps are your actual critical control points. We don't want to make the mistake of having too many critical control points, and I'll give you an example. Coming back to that chicken and salmonella, the processor cannot guarantee that there's no salmonella on that chicken. They can't. So having an approved supplier is important. It's not a critical control point. Neither is the receiving step, because at receiving, you're not doing anything to prevent the hazard from being there, or to eliminate the hazard, or to reduce the hazard to an acceptable level. Same thing with refrigerating that raw product. Once again, all you're doing is preventing growth. You're not preventing the hazard from being there, or eliminating it, or reducing it to an acceptable level. Only the cook step will be your critical control point at which you destroy salmonella in that chicken. Are there any questions at this point? And yes, the flow diagram is required to be a part of the HACCP plan in some form. Okay. 7 principles of HACCP. First one, once we have done those preliminary steps, we need to do the hazard analysis using those resources that we provided for the biological, chemical, and physical hazards. We use the risk matrix to determine what hazards we must control and at what steps we must control those hazards. We have to consider all the ingredients and not just the proteins in the process itself. Why do we have to consider the ingredients? I mentioned the example of Worcestershire sauce. This is an ingredient. It's not the product itself, but depending on your supplier, it may or may not have anchovy. So if it has anchovy, then we have to declare fish as a potential hazard, an allergen. Some processes, such as reduced oxygen packaging, can introduce a potential hazard due to the process itself. When we remove the air from the package, it creates that ideal environment for Clostridium botulinum to multiply and produce toxins. So we have to have refrigeration. We have to have date marking to control the potential hazard. Once we have identified the potential hazards, we need to determine what steps we have to control those significant hazards we've identified. So salmonella in chicken, we know that cooking step is where we have to have a CCP. What you need to know about cooling processes is that if you have spore-forming bacteria such as Bacillus or Clostridium, your cooking step is not going to be hot enough to destroy the spores. So we have to have proper cooling as a second CCP, because we want to get through that temperature danger zone quickly in order to prevent those spores from having enough time to activate, produce cells, and produce toxin. So again, that would be another critical control point step. Because of the fact that there's no other policy or general procedure outside of the HACCP plan that can provide effective control. There's no plan B. It is your last chance to deal effectively with that potential hazard. Drop in the chat, why can employee health not be used as a critical control at a critical control point? Why can't we use employee health as a critical limit at a CCP? It's not measurable, right? If you were during COVID, we had to check people's temperatures and things like that, but that was no guarantee that they weren't carrying the virus, right? Same thing with norovirus. If someone was exposed, we can't be sure of that, whether they're actually infected or not, unless they're actually showing symptoms. So we cannot use something like employee health as a critical limit at a CCP, although it is an essential control. So we have to be very careful to understand that CCPs are not a critical control point itself is not a temperature, it's not a time, it's not sanitation, it's not employee health or hygiene. Those are all essential, but it is the critical limits that have to be measurable, have to be observable. So cooking temperature and time, label content. If you're running a meat market and you're needing to provide cooking and storage instructions on the packaged product, that content is critical on the label. If you're cooling cooked foods, sous vide or ROP cook chill, there are two phases. Each has two critical limits, the elapsed time and temperature. So we have to make sure that we provide those proper critical limits per the food code in these ROP processes. It is possible to have more than one critical limit at a single CCP, cooking temperature and time, cooling rate from 135 to 70 within 2 hours, and 70 to 41 within 4 additional hours. So those are some good examples of pairs of critical limits at a single CCP. Any questions about CCPs and critical limits?
We have a question that came in a little earlier before you started.
Okay.
It says, is ROP limited to bags? Or for instance, what about like mason jars or deli containers? Are those acceptable for preservation of chicken salad? I think she meant to say pimento cheese beyond the 7-day food code, and of course the required variants.
Okay, so chicken salad, for example, if we package that in a lidded container, I'm gonna pick one, like a Rubbermaid container with a snap-on lid, that is not a hermetic seal. So that would not be considered an ROP container. Same thing with Ziploc bags. They are not considered an ROP package. Let's see. Mason jars typically would be used for canning, which is an ROP process if the jar is hermetically sealed, but that's also going to be associated with an acidification process, and it should also follow a required time and temperature prescribed by a process authority. So the primary process there is canning and not reduced oxygen packaging. The acidification properly addresses the control that's required for that reduced oxygen package. So in that situation, we're using acidification and a prescribed thermal process as opposed to 350212 controls for ROP. I hope that helps. Okay. Any other questions before I move along? Okay. I see a question there about elaborating on the label content. So the basic requirements in 360211 of the Food Code include that the name and address of the producer must be on the label, the product identity and ingredients, and net weight statement and allergen declaration. In terms of the allergens, there's two ways to do that. If the name of the allergen is evident in the ingredient list, then you could bold that. So let's say you have a recipe that includes, let's say you've got a breaded chicken product. It's raw breaded chicken. What is in that breading? If it includes a wheat product like flour, when you list the ingredients, you say flour parenthesis wheat. If the name of the allergen is immediately evident, such as let's say there's Worcestershire sauce, so that's one of your ingredients in the product. You would have a parenthesis with the ingredients in the Worcestershire sauce, and if it includes anchovy, you could bold anchovy, or you could say anchovy, sub parenthesis, fish, end parenthesis, parenthesis. The other way you could do it would be to, after your ingredient list, put a contains statement, contains fish. So there's a couple of ways to handle that. But as far as, let's say you're selling product to the consumer to be cooked at home, because of the fact that you are selling that raw product that needs refrigeration, it needs a date mark per 350-212. You need to provide that additional information to the consumer for proper storage, including a shelf life time, and for proper cooking. So that those would be the additional pieces of information you need to provide, because you're communicating specific HACCP controls to the consumer. Whether they follow those or not, that's on them, but you still need to provide that information. Does that help? Can't control the consumer, but we can and must provide the right information on the label. Okay. So we've done the critical limits. How do we know that we're meeting the critical limits? That is where we have to have monitoring. So we have to talk about, what are we going to monitor? We're going to monitor cooking temperature. How are we going to do that? We're going to use a calibrated thermometer and check 1 or 2 or 3 pieces per batch, whatever is going to be your plan. See, that's the what, it's the how often. Could be each batch, could be daily, could be twice daily. It just depends on what you're doing. If you're doing sous vide cooking or ROP cook chill, there is a couple of requirements we need to talk about. The cooler temperature must, where your product that has been packaged and stored, where that product is being stored, you're required to check that cooler temperature twice a day, and to have an electronic temperature logging device that continuously logs the temperature, and it is continuously recording, so it must be inspected twice daily. So in your template, the refrigerator freezer temperature / date mark log includes a statement in the header that says something to the effect that by signing this log, you are attesting that you have also inspected that temperature logging device twice daily as required. So that means taking a look at the data and making sure that it is actually recording temperatures. It has not stopped. So suggest you have battery backup on that device. They're not expensive, but they're a great way to potentially save product. If you have a power outage, if you're continuously recording that data and you can show that the cooler never went out of temperature even though the power was out for 3 hours, then you've got data to support not throwing that product out. If it goes out longer and the temperature of the cooler starts to go up, you can temperature map the product in the cooler to see what the temperatures are. And if the product temperatures are still 41 or lower, you could ice it down, maybe move it to a different cooler, maybe cook some of it off. You've got more options, but again, it is worth having that temperature logging device, and it must be inspected twice daily for operation as required. Let's see here. So again, monitoring the critical limits, and then it must be assigned to somebody. Simplest way to address that is trained staff. So going across line columns 4 through 7, what are we going to monitor? How is it going to be done? Calibrated thermometer. How often does it happen, or when does it happen, and who is responsible? Those 4 items do not need lengthy explanations. It can be very brief answers. And then once we have assigned the method of monitoring, if we fail to meet any one critical limit, what is the corrective action? We have to have at least one corrective action pre-planned for every foreseeable failure. So if we fail to cook the chicken to the right temperature, what's the corrective action? Continue cooking, right? If the cooler goes out of temperature, what options do we have for corrective action? I kind of alluded to it a few minutes ago. If we have that temperature logger, we have more data on which we can base a correct decision. If the food has been out of temperature no more than 2 hours and we can prove it from that data logger, then maybe we can move it to a different cooler. We can ice it down. Maybe we can cook some of it off. But if it's been out of temperature more than 2 hours, the food itself, now we may not have enough time to cool that product down to below 41 degrees. So now we've got to start thinking about throwing it out, right? Again, corrective action needs to think about each critical limit that you've identified and what corrective action do we need to take to get the process back under control and to fix the process. Those are the 2 critical factors in every corrective action. Got to talk about cooling here. The requirements in 35014 Food Code are to cool from 135 to 70 within 2 hours. If we get to the 2-hour mark and we have not reached 70, we need to discard the product. If we are checking the temperature more often, let's say hourly, and we've started at 135 and it's still at 125 1 hour later, right now we can reheat to 165 and then change the cooling process to be more aggressive. Maybe we need to split the batches of product into 2 separate ice baths. Maybe we need to do something different, blast freeze or whatever. The point is we need to plan for the appropriate corrective actions, and how will we decide what is the corrective action that is going to be correct? Going on with cooling, if we do not reach 41 degrees within 4 hours after reaching 70, once again, we have to discard the product. Again, this comes back to those spore-forming pathogens, allowing them too much time in the cooling process to where those spores can activate and produce toxin. So again, those critical limits are not negotiable. Once we get to the specified time, 2 hours or 6 hours total time, if we have not met either of those critical temperatures, then the product must be discarded. Something else we need to talk about here, internal versus external temperature monitoring. We occasionally see someone using an infrared thermometer for this, that, or the other. Be aware that, number one, that only checks external temperature. It does not check internal temperature as required by the food code for cooking temperatures. But you also need to realize that using an infrared thermometer, or a laser thermometer as they're sometimes called, is very finicky. And if you're pointing that at let's say a glass jar with a clear or semi-clear liquid in it, you're not going to get an accurate reading. You will not. I can tell you that from experience. You have to be pointing at an opaque surface, no light transmission. So you're really better off with calibrated probe thermometers, either dial type or digital. Infrared thermometers are really not the best thing to be using in a restaurant kitchen. So the monitoring method has to be able to provide reliable data. Establishing corrective actions. In an effective corrective action, we have to identify what went wrong and why it happened and what was done to correct it. What do we do with the affected food? And how do we fix the process to bring it into compliance? So the records that you create provide opportunities for process improvement. For example, if you, and this is a common violation, if we see product that was not cooked at a proper temperature according to the cooking log, such as turkey cooked to 158 degrees, we know that's not a correct temperature, especially if we don't know how long it was held at that temperature. So that is an issue that requires a corrective action. Either a specified time based on FSIS Appendix A, or just cook it to 165 as required by the food code. So the cooler is out of temperature. What kind of corrective actions do we need to think about? How can we use temperature logger data to help us make the right decision on what actions we need to take? So you want to provide the options, your HACCP summary table, your CCP chart. You don't need to write paragraphs, but there may not be enough room to write every possible thing. But that is where part 4 in your template is important, because you do need to provide the complete correct instructions there in part 4 of your template. Any questions at this point?
None so far.
Okay, perfect. Okay, important to differentiate correctly between validation and verification, and monitoring for that matter. Validation is, and this is the official definition here, it's obtaining objective scientific evidence that the proposed procedure or critical limits will be effective looking forward in time if in achieving the intended purpose, if they are implemented correctly. So once again, it's just you're obtaining evidence that your proposed process or critical limits will be effective in achieving its intended purpose going forward in time as the plan is implemented. It is a forward-looking activity. So the critical limits from the regulations are already validated. Times and temperatures, pH, water activity. Sources of validated information include FDA and USDA. In some processes, you can use processing authority data. Here in South Carolina, we partner and work very closely with Clemson University Extension. So they do, analyses for pH and water activity, water phase salt. It may be necessary to obtain a challenge study to determine whether a product's recipe is robust enough to prevent the growth of pathogens of concern. That's important with determining shelf stability. So same, shelf life. Basically, challenge study is typically what's going to be required for that. So again, process authority data or data from an approved and qualified commercial laboratory can provide the same information, but they cannot provide thermal process recommendations. So if you're canning, for example, you need a process authority's process letter. Verification, on the other hand, is a backwards look in time. It's looking backwards to see that the process did work, past tense. Was it effective, or were there corrective actions needed? Were those corrective actions followed? Were they effective? So when you write a verification statement in your HACCP plan, that chart, the CCP summary chart, and in your standard operating procedure, the basic elements of a verification statement would include who is responsible for that activity and what is the required activity and how often or when schedule. When is that activity scheduled to take place? Typical activities would include records review, not writing down cooking temperatures or cooler temperatures, but actually reviewing those records as the manager to make sure that proper temperatures and times are met and so on. Reviewing those data records, potentially also observing employees as they are conducting those monitoring activities to make sure they're being done correctly. So who's responsible? What is the required activity? And when or how often does that activity take place? What is the schedule? If you say it's going to happen weekly, but then things get busy, like in the holiday season, Thanksgiving, Christmas. If you have said weekly and things get really crazy, it's going to start slipping, right? It's just life. So if you specify a schedule based on, let's say, what is the slowest day of the week, that's when we're going to do our verification records review. That's when we're also going to do our thermometer calibration checks. So schedule according to what works for you, but keep in mind, verification is not the same thing as monitoring. Monitoring is real time, checking temperatures, checking expiration of date marks, checking coolie rates, and so on. Those are monitoring activities. Verification comes down to records review, observing employees as they do their monitoring, and calibration of instruments that are used for doing the monitoring, such as thermometers. Verification also includes periodic review. I would strongly suggest, and I managed a laboratory for 16 years, and I could tell you that what made my annual review a lot easier was keeping records of my more frequent review of all the records and noting particular issues. I used a spreadsheet, and we standardized the language. It was shared between everybody in the lab. So let's say we had a corrective action for date mark failed, date mark missed again, or improper cooking temperature, improper. Keep records of those things. That will make your annual review a lot easier. You can review those reviewing records. That will greatly help your annual review reassessment process. If there were other problems that came up with the process, you should be keeping notes of that to simplify that annual review. When you do that annual review, you can always contact myself or Kim Messick here in South Carolina. If you have questions about the review, if there are changes you want to propose, contact us before you make those changes so we can provide you with the necessary guidance. If you've got an approved plan, for example, and you want to add, well, let's say you've got an approved plan for ROP storage of beef, pork, and chicken, and you decide you also want to vacuum package fish. You can amend your approved HACCP plan to include fish. We will make a copy of that approved plan. We will provide guidance marked as review comments to say these are the places where you're going to need to make some updates. We'll send it back to you, let you make the updates, and then we'll go from there to see if you have met the necessary requirements. So the point is, we are your partners. Please, 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 if you have questions, contact us before you go making changes so we can provide that necessary guidance. We have to make sure, though, that any changes that result from updates to your plan are appropriate. We also have to make sure that your plan is up to date with the regulations. If suppliers have changed, procedures have changed, products, equipment, those changes must be addressed in your HACCP plan. So if you have something that happens in the middle of that annual review year, let's say you have to replace some equipment that requires an update to your plan. So once again, verification is a backwards looking activity, looks back in time. It is not a monitoring activity. Basically, it provides the evidence that your plan is continuing to be valid as written. It's just a review. It's an effectiveness review. So it's a feedback loop telling you how effective your plan is or is not. Questions? Okay, so the last of the 7 principles of HACCP is record keeping. Bottom line, if it was not written down, it was not done. You need those written records to document the monitoring and any corrective actions to demonstrate that you're in compliance with the regulation and you're in compliance with your contract with the regulator, which is that HACCP plan. Validation records are important, such as product assessments you may have had to get, process letters and process authorities, which typically that would not apply to ROP processes, but it's important to keep in mind that those are HACCP records, which you must keep on hand. Verification records, notes that you make as you review your monitoring data. Your records can be paper, they can be electronic, as long as they provide the necessary information. You could use forms other than the templates we provide, or the example monitoring logs we provide in your HACCP templates. As long as they provide the right information, you could make your own forms, but they must provide the required information. So that record keeping is not optional, it is mandatory. So there is HACCP monitoring software out there. We cannot recommend software or equipment to you, but it's definitely worth searching for that information. For example, if you are doing sous vide cooking, it is well worth getting a sous vide temperature monitoring kit with an app that records the data. You can put that probe in place in one of the pieces of product in a batch using self-sealing foam tape, get a needle, thermocouple probes, Bluetooth connection to the app, put it in there, and it can record your entire temperature profile from come up time to cooking time to cooling. All one record. Save that to your computer as a permanent record, and that will replace a cooking log and a cooling log. Just keep that as a permanent record. So yeah, it's important to look for ways to simplify as long as they're acceptable. Electronic records are fine, again, as long as they provide the required information. So take advantage of technology when you can. Tim, I see you have a question there. We're going to take products from different farmers. What records do we have to have from the farmers? Well, you want to know that they are approved by the regulatory authority, whatever state, typically probably a Department of Agriculture if it's produce. If it's a livestock, probably USDA. You want to make sure they're operating in compliance with the applicable regulations, whether it's produce safety rule or USDA regulations. So you want to make sure that supplier is operating in compliance with the applicable regulations. So a letter of guarantee is kind of a basic documentation that the supplier is in compliance with the regulatory requirements for whatever their operation is. So yeah, and Kim has provided you a really good answer there. So I hope that helps. Okay. Knowledge check. Which of the following must be considered in performing the hazard analysis? What's the best answer? A lot of A's, and that is correct. Very good. Let's see if I can mouse where it's supposed to be. Next question. Which of the following statements about critical limits is not true? Not true. Seeing a whole lot of D's, I'm seeing a few others. If the critical limit has not been met, that may result in unsafe food. The cooking temperatures and times are absolutely important because they are validated for destroying your bacterial pathogens. A critical limit can be a numerical value or an observed detail, such as the content on a label of product that is being sold to the consumer for home use. Critical limits always must be backed by accepted science, whether it's published by the Food Code or USDA or provided through a product assessment. We had an example not too long ago where a process had to be validated by the University of Wisconsin, and they provided some controls that were really kind of surprising to us, but they provided the evidence that those controls would be effective given the nature of the process. So you have to have science supporting those controls. But if um, corrective action is not always required, if the critical limit was not met, that is not a true statement. Corrective action is always required if the critical limit was not met. Okay. Another question here. Which of the following statements about corrective actions is not true? Not true. I'm seeing a lot of B's. I think I saw a couple of other answers. So corrective actions must address the affected food and they must bring the process back into control. That is true. There may be more than one acceptable option for corrective action. Icing down product in the cooler where the cooler's gone out of temperature, or moving it to a different cooler. Either of those would be acceptable. In some cases, it may be an option to cook off some of the product if it was out of temperature no more than about 2 hours. Along with required monitoring records, corrective actions must also be documented. That is true. The statement that is not true is that if a corrective action was required by your HACCP plan, the food's probably safe. The whole concept of a critical control point is it is the last step in the process where you can apply a specific control to prevent, eliminate, or reduce to an acceptable level a hazard that you have identified as significant. So you cannot be sure that if corrective action is required, that the product is probably still safe. You cannot make that assumption. Because if the critical limit was not met, then you have not met the criteria that are necessary to eliminate or prevent or reduce to an acceptable level that potential hazard. Okay. So how do we verify compliance with a HACCP plan? When the inspector is getting ready to come to your establishment to do an inspection, here in South Carolina, the way that is supposed to go is that your inspector will pull your file from our special process directory on SharePoint. They will review your HACCP plan. They'll be looking at the products, the flow diagram, the intended use, who's going to be trained. They will be looking at that CCP audit table to identify the critical limits, what monitoring measures you have in place, corrective actions, and the records. They'll be looking for all of that. At the very least, they'll look at those very first 2 to 3 or 4 pages in your plan, as well as that CCP summary table and your standard operating procedure to get familiar with your plan. If they then, during the inspection, find that they're seeing things that are different from what you have written and gotten approved in that plan, then you're going to have a violation. So that is how the inspector will prepare for doing that inspection, that verification audit of your process. During the inspection, the inspector will review records to identify potential gaps in your compliance. You want to make sure that you're actually keeping the proper records and that you're following the process as written and approved. Keep in mind, your plan is expressing your commitment. It is a contract. You're expressing your commitment to follow the approved process. If you have changed procedures, ingredients, that needs to be approved before you implement that, or you will no longer be in compliance with your approved plan. So your establishment bears full responsibility for the accuracy of those details in the plan and for fully implementing and complying with the plan. Our role as the Department of Agriculture, the regulatory authority, is to verify that your controls are backed by accepted science and to provide guidance to steer you towards the correct controls when that guidance is needed. If you need flexibility in your recipes, that needs to be built into the plan. So If your plan is approved for just a certain set of recipes, then you go modifying some of those recipes, there's a potential that you may no longer be in compliance with your plan. So that's where, before you make those changes, talk with your inspector. You're in South Carolina, you can talk with myself or Kim Messick, and we'll provide guidance to help you with those modifications. Let's see here. Some of the most common HACCP violations that our inspectors see include improper labeling, products not properly labeled, or maybe date marks have been changed, products held past the allowed shelf life or not date marked at all, improper cooling or multiple cycles of cooling. So cooling, reheating, cooling again. Keep in mind that if you're cooling properly, but you put it through multiple cycles, if there's somebody in there producing toxin, that toxin accumulation can potentially become a problem. You're only allowed one pass through the cooling cycle from start to finish. Same thing with ROP packaging. You're only allowed to package one time. Once it's been removed from the package, it cannot be packaged again. Processing unapproved products. So if we have a plan that's approved for ROP packaging raw chicken, beef, pork, lamb, and you decide to start packaging fish, if it has not been approved, then that's an issue with compliance. Process not being followed as approved. You're changing procedures. Again, that you've voided the approval of the plan. Packaging fish in standard ROP bags without freezing the fish or improperly thawing the fish, and then the required monitoring records not being maintained. All of these are some of the most common violations that we see. So now we're going to get into the ROP itself. These are all the processes that require regulatory approval. Reduced oxygen packaging is just one. So I'm not going to spend a lot of time on that. ROP can be used in combination with other processes, such as acidification. We've also seen it in combination with curing processes. So sometimes there are hybrids, but we work with you on whatever those situations are. We have templates for hybrid processes as well as just the standard like ROP. Coming back to the definition of TCS food, right now the current definition is time temperature control for safety. Ready-to-eat foods require shelf life of 7 days or less when they're stored at 41 degrees or lower. This is a safety date. That means consume or discard by the assigned date. Exception would be that if the product is frozen, while it is frozen, shelf life is not limited for safety. It may be a quality issue, but it's not a safety issue because nothing happens while that product is frozen at like 10 degrees or 20 degrees or minus 10 degrees or whatever. Another exception would be foods in which either the water content or the pH, such as higher pH values or both, higher acidity levels, so lower pH, or both are used to reduce to a level that does not support growth and toxin formation. So we repeat that. So an exception to the normal TCS ready-to-eat food rule would be products in which we've modified either the water activity or the pH to make it more acidic, or both to reduce these characteristics to a level that does not support growth and toxin formation. So a great example of that is fermented sausages, where we change both pH and the water activity. We're drying the product after it's been acidified by bacterial action. So the list you see on screen here is the list of products that are defined as time temperature control for safety food based on what the food code says right now. Preservation, once again, is taking that TCS ready-to-eat food and extending its shelf life beyond 7 days or making it shelf stable, or both. So if we, for example, dry jerky, we're taking a TCS ready-to-eat food and we're drying it first of all, but then we're also extending its shelf life to much, much longer than that 7 days. We're making it shelf stable. It doesn't require refrigeration. So let's see. We'll move along here. So these are the interaction tables that I referred to either earlier. The table on the left is only for canned foods, properly hermetically sealed cans. The table on the right is what we use for everything else. So, for example, if we have a product that has a pH of 6, column it all the way over to the right, and the water activity is greater than 0.92, it says PA, that means product assessment. That means that a product assessment would be needed to determine if the product will not support bacterial growth, even though, according to the chart, it is a TCS food. So if it doesn't say non-TCS, it says PA instead, it is a TCS food unless a product assessment proves it cannot support bacterial growth or toxin formation. So this is where we can, modify some of those characteristics. If we're curing meats or if we're making, pickled products or fermented foods, that's where we're working with the water activity and the pH to hopefully make the product non-TCS or at least extend the shelf life. Reduced oxygen packaging. Before we jump into that, are there any questions that I can answer? Any questions I need to take care of? Good. Okay.
I think we're good.
Okay. All right. So reduced oxygen packaging is defined as any packaging process that reduces the oxygen content of the headspace in the package below the 21% that is found in air. Air is 21% oxygen. If we reduce the amount of air in the package, then it is an ROP process. There are different forms of ROP. If we vacuum package, that is one because we're completely removing the air. Controlled atmosphere packaging is typically used with jerky, where we have a sachet of a chemical in there that controls the atmosphere by removing oxygen from the package. Basically, that sachet contains iron filings, which will grab that oxygen and they'll start to rust in that sachet. So that maintains a lower oxygen content than normal air. And it controls that oxygen level it reduces it and controls it at a lower level of oxygen. The other type is modified atmosphere packaging. A couple of examples of that would be if you go to the grocery store and you purchase hamburger patties that are in a black tray with a kind of a bubbled up clear plastic film over the top. That is typically because it has been filled with another gas like carbon dioxide or maybe nitrogen. And then potato chips or any kind of, those junk food products that are in bags. It's about half full of product and the rest is just kind of puffy. Those bags are filled with nitrogen. The reason for that is to prevent the oils in those products from going rancid. You don't want oxygen, so you replace it with a different gas. The picture you see here is a couple of sous vide baths, temperature controllers. So that's what we're talking about there. The two primary hazards in all reduced oxygen packaging processes. Number one is Clostridium botulinum. We call it CBOT. Produces a toxin. Those spores are present in the environment. So it favors a 0% oxygen environment. The land-based strains that could be associated with any kind of, whether it's meats or produce, have to have a temperature of at least 45 to 50 degrees to be able to multiply and produce toxin. But then the strains that are found in fish products that live in the water must have a temperature of 38 degrees or higher to be able to multiply and produce toxin. So this is the reason why we have to treat fish separately in ROP. The other one is Listeria monocytogenes, which is an environmental pathogen. It's found in soil. It can be found on packaging materials, on people's shoes and clothing. It is a major concern in any food production environment. So we have to be very, very careful to do our sanitation just very, very carefully. Make sure we are eliminating places that harbor food residue. Tiniest little places can become a big, big problem. It can grow as low as about 30, 31 degrees with or without air. So listeria is our other major concern. It is the specific reason why date marking of TCS ready-to-eat foods is required because of that. So 7 days or less shelf life is specifically to control Listeria monocytogenes in those ready-to-eat foods. When we control these organisms, we will also effectively control other pathogens such as E. coli, Salmonella, and Campylobacter. Remember the growth curve that we looked at earlier? Reduced oxygen packaging is a method of extending that lag time, that first part of that growth curve, by removing air, so that greatly slows the rate of growth. And that is how we extend the shelf life, for example, in raw meats. So it is a preservation method for that reason. The requirements of the food code, like I said, we are currently on the 2017 version. Here in South Carolina, we're in the process of updating to the 2022 food code. For packaging of raw meat and poultry, we are allowed 30 days of storage at 41 degrees or lower with a HACCP plan. That is also 30 days allowed for commercially cured meat or meat that has been cured in-house, meeting the same requirements as for cured meat coming from a USDA inspected facility. Foods that have a pH less than 4.6 or water activity less than 0.91 are allowed. Foods at a high bacterial load, which basically is going to apply to all raw foods. Hard and semi-soft cheeses, and if you're not sure whether a cheese is allowed, you can look at 350117 in Annex 3 of the food code, and there is a good list there of hard and semi-soft cheeses. Here in South Carolina, we occasionally run into some chefs who want to package other cheeses that maybe they've imported from Europe, some goat cheeses or raw cheeses. So we have to go to the pasteurized milk ordinance. We also may have to ask for information on the percent solids content or the percent moisture content of those cheeses in order to determine whether they qualify as hard or semi-soft. Hard cheeses are defined as having 39% or less of water, moisture. Semi-soft cheeses are defined by regulation as having less than or equal to 49% of moisture. So if the cheese meets those criteria, then potentially it's allowed. And if it is a raw cheese, it must have been aged for at least 60 days, and that is per the pasteurized milk ordinance. So once again, that's a very useful table. And if you are looking at some cheeses that are not listed in that table, you would need to know what the characteristics are of that cheese to determine whether it can be allowed or not. I can tell you that soft cheeses like queso fresco, mozzarella, those types of soft cheeses, they would not be allowed for reduced oxygen packaging. The other thing to keep in mind is that if you freeze a product after it has been packaged, date marking, you'll need to be able to track that time. If you freeze it immediately after it was packaged, you have stopped the clock. You have used day 1 of the shelf life. When it comes out of the freezer, the clock resumes at day 2, the day it comes out of the freezer. So for a raw meat, you've used 2 days out of 30. So now you have 28 remaining days after it came out of the freezer. You would need to be able to track that time with a pull date that came out of the freezer, and then a use by date 28 days later, using that particular example. Let's do a knowledge check here. What are 2 required critical controls for ROP packaged raw meat or poultry in storage. I am seeing a lot of Bs. So freezing and date marking are not required. Refrigeration 41 or lower, expiration date and salt is not required. B and C, typically we see both. What is actually required is C, but B, but the expiration date is also typically on the label because of the fact that you want to make sure that it's tracked correctly. Packaging date is required by the food code, but the expiration date typically is also going to be marked because you want to make sure it's counted correctly. Again, the day it's packaged is day one. So from the day it's packaged for a raw meat, you have 29 additional days. If you go to 30 days, then you're out of compliance with that date mark requirement. ROP of fish, it must be frozen before it is packaged in standard ROP packaging. It requires some modified HACCP procedures or a variance SOP. When I say a variance SOP, that would be if the fish is going to be, obviously it has to be frozen, but if it's going to be removed from the bag within 48 hours of frozen storage, then we in South Carolina would treat that as a variance just because we have to document that process. So we will call it a variance even though technically it is not such. Sous vide of fish, that question came up earlier. It does require modified procedures. We have validation that we wrote up with help from Rutgers University and NC State. I will be submitting that to the Conference for Food Protection this year for FDA to consider. We provide that if you're wanting to cook fish in South Carolina using sous vide, we're going to talk with you. We're going to provide you with that additional validation information. Not all jurisdictions are comfortable just because of the way the food code is worded, which is, sorry, it's a big hot mess, but there is validation available, and we do use that here in South Carolina. Sous vide plans require a continuous preparation process from bagging to removal from the bag in as short a time as possible. So if you think about time and temperature, if you bag that fish and then immediately cook it, or let's say you even bag it while it's frozen, add the other ingredients, seal the bag, put it in the bath, cook it, and then immediately remove it from the package, you are strictly limiting the time that thawed product is in that vacuum package. Time and temperature are critical. Remember that FAT-TOM acronym? You're strictly limiting the time. So if it takes 2 hours from the time you seal the bag to the time you take it out of the bag, that has not allowed enough time for any toxin to form from Clostridium. It does require variance because you're using an alternate method to control that pathogen. But this is one science-based method where you can cook fish sous vide. I mentioned octopus earlier. Lobster is another one. There's some other variance possibilities that really get into seafood HACCP, which I'm not going to get into here. But again, we have validation that we have written based on seafood HACCP that we provide to our customers in South Carolina when necessary. But that validation does have to be provided as part of the HACCP plan. Sous vide cooking. So obviously cooking temperature and time are critical limits. Proper cooling is required. Again, 135 to 70 in less than 2 hours, or no more than 2 hours, and 70 to 41 in 4 hours or less. It is allowed no more than 7 days storage under refrigeration with a HACCP plan. You are not allowed to take that product out of the package and then repackage it for some reason. That is not allowed for any ROP process. Here in South Carolina, if the product is going to be stored no more than 48 hours under refrigeration, we only require you to write a procedure, not a full HACCP plan. That is the specific provision in 350.212F. Some things to think about with sous vide cooking that we have run across a number of times. Number one, I mentioned earlier, sous vide cooking may often be done at low temperatures that are too low to destroy viruses. So employee health and hygiene policies are absolutely critical. Cannot monitor those, but they are required process controls. Something else we have run into repeatedly is cooking large quantities, large batches, or even large roasts. We've had a couple instances where someone was curing hams and then cooking them sous vide, 20-pound hams. So the concern here is excessively long come-up time from cold to cooking temperature. So we're allowed no more than 6 hours. That is in the food code. The concern there is staph toxin formation that can occur on the skin of the roast. So you're going to need to think about specifications for the batch size. What is the maximum capacity for that bath and circulator to get that batch of product up to temperature within no more than 6 hours? To cook large roasts, do you need to break those down into smaller portions? Do you need a larger bath, maybe even a larger bath with a second or even third controller? Do you need to set the initial temperature of the controller higher than your desired cooking temperature until you get above 130 degrees and then adjust it to the required cooking temperature? So there's a number of things that you would really need to think about if you're dealing with large batches or large roasts in order to make sure you're meeting that come-up time requirement for safety. The volume of water in the bath, the amount of product, proper circulation of water in the bath so that all the product is being heated uniformly. Absolutely essential to monitor the internal temperature of the product. You cannot determine that it's properly cooking by checking the external temperature, especially of a large roast, because the internal portion is what will both heat slowest and cool the slowest. You absolutely need internal temperature monitoring. That is where a sous vide temperature monitoring kit really becomes essential. Self-sealing foam tape, a Bluetooth needle probe thermocouple, and an app that will track that internal temperature. We cannot provide recommendations, but here in South Carolina, Clemson Extension is a fantastic resource for all kinds of technology solutions. We can provide that contact information to you. It's also important to provide for consistent portion sizes and not overcrowding the sous vide bath. That water has to circulate freely. And then lastly, with sous vide cooking, the product that has been cooked must be stored in a cooler where you have a continuous electronic temperature logging device that must be inspected twice daily for operation. Use that data. Like we talked about earlier, you can use that data is to just, if the cooler goes out, you've got battery backup, that device should be able to give you a notification. Hey, the temperature is rising. Gives you time to do some sort of preventive action before you end up having to start throwing product out. So it's well worth a minimal investment to get that in place. When we talk about cooking processes, we talk about having a friendly bacterial population, but when we have cooked the product, we are destroying the friendly bacterial population. I love this Where's Waldo thing. I made 2 Waldos into salmonellas, and that's what happens when you cook that product. So now the salmonellas potentially survive because they need a higher cooking temperature. So now they have no competition. So this is why we have to really pay attention to sanitation. We want to make sure we use validated times and temperatures for cooking to destroy the pathogens we're most concerned about, like salmonella. Cooking below 150 will not destroy norovirus. Cooking below 190 will not destroy hepatitis A virus. Once again, employ health and hygiene practices. Spores of Clostridium or Clostridium perfringens will also survive low and normal temperature cooking. Toxins will not be destroyed by anything like normal cooking temperatures. So when it comes to sous vide cooking, you want to be really careful that you don't overproduce. I still remember very painfully a customer who got marked out for having sous vide product that was as much as a month past its allowed 7-day shelf life. And it was very painful. The customer had to discard that product. Don't overproduce. If you can see that you're not, let's say you have a party that's scheduled for this coming Friday, and well, today is Thursday, and the customer says, we're going to cancel. Now you got all this product you've overproduced. Put it in the freezer and make a plan to properly track the remaining shelf life. If it was prepped on Wednesday under a HACCP plan, you have 2 additional days to Friday. So on Thursday, you're told it's going to cancel the party. You have 5 additional days left. Put it in the freezer and be prepared to track that remaining time. So those are some things to think about. And again, continuous electronic temperature logging, once again, is required for ROP cook chill processes. But again, please make sure you don't overproduce. And if you find yourself in that situation, act promptly to freeze the product, or maybe cook, maybe run a special to get some of that product off your shelves and served out while it's still within its shelf life. ROP cook chill. The product is cooked and then it is bagged at or above 135 degrees for safety. And I need to point out that 135 degrees is not a CCP. It is not a critical limit. FDA has not provided a time requirement for that temperature. And having looked into this question for, it had come up several times, what I found is that the listeria can actually survive at 135 degrees for several minutes. So to make that a critical limit, you would have to have a validated time at that temperature. So it is not a critical limit, but it is a necessary control. Cooking temperature and time will be critical limits. Proper cooling, same thing, critical limits. If the product will be hot held, it must be reheated to 165 for at least 15 seconds within 2 hours, and then properly hot held. And while it's in storage, the product is allowed no more than 7 days shelf life at 41 degrees or below. Again, or you can freeze it. Again, you are not allowed to repackage the product once it has been packaged once in your establishment. So, and again, if you are doing ROP cook chill, let's say it's a catering operation, you package the product, cook and package the product today, cool it, cold hold it, go to a catering event tomorrow, you could do that under a so-called variance SOP, where it will be stored no more than 48 hours under refrigeration before it is removed from the bag.
We have a question.
Okay, go ahead.
You kind of hit on this earlier, but if you can hit on it again. It's for Georgia. They're wanting to sous vide for 2 hours, put on the grill, no cold storage, with toss leftover product. What is basically needed for that? Is it HACCP plan a variance?
Could you ask the person to open up their mic and just kind of restate the question, please? I just want to make sure I understand the question clearly.
Yeah, so in our restaurant, I don't want to serve steak that's been sous vide overnight, or chill it and then reheat it or anything like that. I want to keep it as fresh as possible. So for us, it's just 2 hours, maybe 3 on the grill during dinner service. If we don't use it, we either toss it or eat it. But we're grilling and picking up right then. We're not cold storing overnight. It's just sous vide machine for for the temperature, basically just to make it easier for our grill guys, and then marking it and then serving it.
Okay, so basically it sounds like a same day operation.
Yes, sir. Mhm.
Yeah, okay. So that would fall under 3502.12F, which says that if the product will be removed from the bag within 48 hours or less, you do not have to write a HACCP plan. All the other requirements in 3502.12 for that product would still apply. You just don't have to have a HACCP plan. Again, here in South Carolina, we do require a written procedure. We call it a variance procedure. It really is not a variance because you are following the requirement of 3502.12F. But
Okay, because I've been told we need a HACCP plan for that by our health inspector. So I'm just trying to figure out what to do.
Are you regulated by Georgia Department of Health or Georgia Agriculture?
Department of Health.
Okay. Well, again, it may come down to agency policy, but per the FDA food code, 3502.12F allows you, if you will be removing the food from the package within 48 hours of refrigerated storage, you do not have to have a HACCP plan. We here in South Carolina only require a written procedure in that situation, so we can document what you're actually doing.
Okay, you said it was 305012F.
3-502.12F. Yeah.
Okay.
So,
Yeah, and my health inspector is in this class too, so I wonder
okay.
if there's a way to
Yeah.
get him.
And I know Colby Brown there at Georgia Department of Health too, so he may be able to help straighten that out.
This one's Adateo. He's on here. I saw him.
Okay. Okay. All right. Any other questions real quickly? We're just going to work through an example here, and then we're getting close to wrapping up. We good? Okay. So in this example, what we want to do, we're going to sous vide a beef steak. So keep in mind, we're going to do sous vide cooking. It's going to be a beef steak. It's whole muscle. So what would be the first 4 steps in this process, starting from receiving? Storage, good. What's next? Okay, we got receiving, we got storing, prepping, good. And after prep, what are we going to do next? Cook, good. Okay. At receiving, what potential hazards, what's an example of potential hazards that we might need to consider at receiving for that beef steak? Hazards, not temperature issues, but potential hazard. Okay, I see E. coli. We need to be specific. Yeah, E. coli is correct. Salmonella would be another. What type of controls do we need in place at receiving or prior to receiving? I see approved source, temperature, yep, supplier, yep, good. Okay, so supplier controls. Is this a critical control point? If you use that CCP decision tree in resource number 9, very good. I see a lot of no's. You are correct. This is not a critical control point. Storage. Once again, we have E. coli and Salmonella. But now in storage, what is the potential? It's growth or cross-contamination, right? Yeah. So if it's not stored properly, we may end up cross-contaminating it. If the temperature is wrong, we could end up growing E. coli or Salmonella. If the temperature really goes out above 45, you have some growth. How do we control that? Temperature and date marking, good. Temperature control. Your storage procedures to prevent cross-contamination as well as the temperature control. At this step, is this a critical control point? Very good. I see no. A lot of no's there. Very good. What about your preparation step? What are the potential hazards there? Employee health, cross-contamination. Yep, good, good, excellent. So let me get my mouse back where it belongs. Here we go. So human transmitted viruses, E. coli, Salmonella, Shigella. I didn't include everything here. It's just an example, but basically your big six. At this initial preparation step, what kind of controls do we need? Employee health, yeah. I see SOP there. Yep. Hygiene practices. What else? Are we missing something? Sanitation, good. Health and hygiene policies, again, for sake of space, I don't have SSOP on there, but yeah, sanitation is also important. Is this a critical control point step? Correct, it is not. At the cooking step, we're still concerned about E. coli and Salmonella, obviously human transmitted viruses too. How are we controlling these at the cooking step? Temp and time, they go together. Always temperature with time. Is this a critical control point? We already know the answer. Yes, it is. So because it's a critical control point, what do we need first? Critical limits, right? So there's the minimum time and temperature combination from the food code. How are we going to monitor that? How do we monitor time and temperature? Calibrated thermometer, right? Calibrated thermometer. Okay. We do the monitoring. What do we have to do if we fail to meet either time or temperature? Continue cooking, right? Okay. Let's see. Corrective action and monitoring. We need a cooking log. We need a thermometer calibration log, right? We need both of those. We need to know that the thermometer is accurate, and we need to document that. Okay. Again, keep it in mind, we're sous videing a steak, so after it has been cooked, what's next? What's the next step in the sous vide process? Good. I see cooling. Perfect. And after cooling, what's next? Cold storage. Good. After cold storage, what's next? Reheating. And lastly, what's the final step? Serving. Good. Good. So at the cooling step, what are the potential hazards? What potential hazards do we have to think about? Spore forming bacteria and toxin formation. Absolutely correct. Is this a critical control point? Yes, it is. What kind of controls do we need here? Temperature and time. Good. So we need a proper cooling rate. So if this is a critical control point, what do we need specifically for that CCP? Right. So we actually have two sets of critical limits, time and temperature for the first 2 hours, time and temperature for the second, or the remaining 4 hours. How are we going to monitor those times and temperatures? How do we actually do the monitoring? There we go, calibrated thermometer. Yes, calibrated thermometer. If we fail to meet any of the critical limits, what do we have to do? Corrective action. Good. Okay. And how do we document what we have done? Logs, records. Yes, perfect. Okay. And that includes a cooling log, a thermometer calibration log. So now the product has been cooled and it's going to be in storage. So now what potential hazards do we have? Keep in mind that a hazard is a specific something that can make somebody sick. It's not a temperature. It's not, yeah. So what we're concerned with specifically, we've already destroyed cells like Listeria, E. coli, Salmonella that could have been on the meat in the package. But there are potentially still spores that survived, right? There's also the possibility, if we don't store it properly, to recontaminate it by cross-contamination on the outside of the package that could then get into the product when we reopen the bag. So primary hazards, CBOT, Clostridium, and Listeria, but then any potential cross-contamination on the package. So those are the things we need to control while it's in storage. How do we control those? And is this a critical control point? It is a correct, it is a CCP, and we control, what do we need to control at this step? Let's see, temperature, what else? Storage procedures, right? We've got to have a storage procedure. How are we going to prevent cross-contamination? How are we, what temperature are we going to require for storage? What about date mark control? All that is part of these procedures. So we've already said this is a critical control point. So what do we need for critical limits? Temperature and time, yes. Date marking, good. Temperature and time. How are we going to monitor? Keeping in mind this was sous vide product. How are we, what is required for the monitoring? How will we monitor? Logs or records, how will we monitor? There we go, data logger, continuous temperature monitoring, exactly. We also have to inspect the labels to make sure that the date mark has not expired, correct? So we've done the monitoring. If we fail to meet either critical limit, what do we require? Corrective action to discard, that is correct. And how do we document all of this? Monitoring records, right? I see log. Yeah. So time, continuous temperature log as well as your temperature and date mark log. It's got to be documented. We're sous videing this product for immediate service. The intent is for it to be served immediately. So when we reheat that product, what potential hazards do we need to be concerned with? Spore formers, correct. If we don't reheat it quickly enough, the spores can have time to activate and produce toxin. So yes, we're concerned with spore formers primarily. How do we control that? Proper reheating, correct. Is this a critical control point? If we are reheating for immediate service, what does the food code require for temperature? We can reheat it to any temperature, right? So is this a critical control point based on that? It is not. That's correct. So for immediate service, we're concerned with human transmitted bacteria and viruses and environmental contamination. We don't want to have come all this way and get this product properly prepared and then serve it with dishes or utensils that have not been properly cleaned and sanitized and stored, right? Is this a critical control point? No, it's not, but we have to have some controls in place, right? What are they? Sanitation and health and hygiene policies. Perfect. Okay, very good. Well, that gives you a good idea of how the process goes. We provide these templates because, for our industry folks, we don't really expect you to understand all that. That's why we provide that information, and we we provide guidance to adjust the hazard analysis if you're doing something different that changes the potential hazards and controls. We provide that guidance to you. But we just want to make sure you have a good understanding. So we also educate through that process as we review the plan with you. We want to make sure you have a really good understanding of the hazards and the required controls. Kim, would you please drop in the chat that evaluation survey link? Your feedback is really important to us. I see a comment there. We're strictly a vegetarian kitchen and glad of it. Well, I hate to tell you this, but produce can also carry potential pathogens. There's no raw commodity that is exempt from that risk. So right now there's the Cyclospora from lettuce. 2 years ago now, there was a salmonella outbreak from organically raised carrots. So, sorry, produce is just as potential to have contamination as meat and poultry. Anyway, so we really appreciate everybody's participation today. We would really appreciate your feedback. I hope this was helpful to you. Kim has dropped in the chat there a link to our evaluation survey. Do have a couple more knowledge check questions, and I want to take time to answer any additional questions there may be, but we will be sending that link out as well next week. We would really appreciate you taking time to complete that survey. Just take a few minutes. Knowledge check question. When we sous vide cook a protein, what safety controls are required besides cooking time and temperature? Very good. D is correct. ROP cooked chill products must be bagged at temperatures greater than 135 degrees to do what? Very good. A is correct. So as we wrap this up, variance is required whenever the process is using procedures or controls that are different from what is required by the FDA food code. So for example, the 10K OTR packaging of fish, we're using additives to extend shelf life, or processing to produce a shelf-stable finished product from a TCS food. If you're writing a ROP storage plan for beef, pork, and poultry, and you also want to include fish, we do not have a separate template for that, but we do provide guidance to show you how to modify the plan to build in the necessary additional instructions for properly preparing the fish and storing it frozen. It doesn't require a lot of modifications, but it's just easier to do it that way than to write an entirely separate plan for fish only. So we provide guidance on that. If you wanted to modify a plan to include fish, then we just provide that guidance. Let's see. Here are some resources that are helpful to you for different things. This is all in the slide deck that we provided to you last week. If you have any questions, I don't know what those squigglies are in purple on the screen, but okay. So the question here is, under the food code 350.212F, we just need written documentation of what we're doing. That is our policy here in South Carolina. I don't know what other jurisdictions are doing. We just feel that it's important to document what you're doing, because if your inspector questions why your ROP packaging and you don't have a HACCP plan, that having that written procedure based on 350.212F should provide the evidence that you need that you're in compliance, but you've got to have an approval letter. Yeah, so Nicholas, if you want to contact me directly, there's my email address, and maybe we can help. I don't know. It may be a Georgia Department of Agriculture policy that they're going to require a HACCP plan regardless. I don't know. I can't answer that, but I do have a contact there who does the review plans, and I could talk with him, and maybe we can figure out what's going on there. But anyway, any other questions before we part ways here?
Do you see Bernice's comment? Can we attend next week's training without writing a HACCP plan?
Yes, absolutely. For inspectors, we do suggest that you use the template we provided to write a plan, because you may come up with questions you didn't think of today. It's just helpful for you to understand the process, so that when your customers ask you questions, you may be able to answer some of those questions and kind of help put them at ease about how the process works. We work with our customers through the process. We educate as needed. We guide you through the process to get the plan done correctly. We really are very serious about partnering with our industry customers to help them get the process done and do it safely. Sydney, I see a question there. I was also wondering if SCDA inspectors attending for standardization. Yeah, it's definitely, in fact, you have attended and you're preparing for standardization. This is a very good thing, because under standardization, you will have to be able to write a risk control plan which uses HACCP principles. That's why we encourage our inspectors to participate in these workshops. I see another question there. You do not need to register again for the workshop next week. We already have you registered. Remember, that was one of the questions on a registration survey. So if you do attend in person, definitely, especially industry folks, and culinary instructors, definitely we encourage you to bring a template, bring your laptop, bring the template you're working on, and we can answer questions for you one-on-one as well as for the whole class. We will be offering next week both in person and online. So Kim will be working with us again. She'll be presenting part of the class, and again, we want to make it as useful as possible to help each of you get your plan written successfully with good understanding of the requirements. Any other questions? Awesome. Well, thank you very much for your attention. A lot of great discussion. Really appreciate that, and I hope you have a great week. And we look